Right, all right, all right. Are we streaming? We should be streaming. I hope we are. I made the mistake of not being ready to check, so now I have to go open Twitch, which you may hear. Or you may not, if I'm quick enough. Ooh, was I quick enough? Oh, I was quick enough. Can you hear me now? Can you hear me now? Hey, you can. That's a good sign. Let's get a little announcement going and do it a little different today. Why not? We'll add the notice right away. We are just going for it. Compiler part 37. Is that really how many of these we're into now? More intermediate representation. Woo! That should be it. Hey, good reminder that my phone is not on silent. Oh boy. Okay. Should be okay. Good to go there. RPWH, yeehaw! How's it going, RPWH? Lander! Lander says, please forgive me for missing last stream. Don't worry about it, Lander, it's okay. I'm glad you're here this time. I wouldn't expect anybody to make it to every single one. I don't even. No, I'm just kidding. Let's get right into it. So let's open it up, Saraid says, yep. What is going on, everybody? It's so good to see you, Saraid, Lander, RPWH. Thank you so much for tuning in. I would like to mention, at the end of the last stream, RPWH donated $10 with the message, thank you for the stream, mister. And I would just like to say, thank you for the $10. No, I'm just kidding. Thank you for watching and for enjoying. And RPWH is now one of the longest running contributors of the channel. Which is awesome. So yeah, everyone give a pog bones or a pog champ to RPWH. Thank you, mister, for being such an amazing viewer. And so much fun to have around. Lando XD says, don't worry, I'll donate as well by the end of the decade. Yeah, maybe just like by the end of 2040, you know, cap it off there. Just setting up a little build command so that we can build and run something. Simple math. Okay, that's not bad. IR load immediate. It's funny we don't have that one. One of the simplest ones. But yeah, just huge shout out to RPWH. Thank you so much. And thank you so much to all contributors to the channel. And yeah, just thank you all to those who are watching right now. Let's get into some coding. So we were working on the intermediate representation, and it looks like our compilation says, hey, you need to do IR load immediate and intermediate representation. So that's probably in CodeGen. So to load an immediate, oh boy. So we're gonna have to insert a new instruction. Yep. Feel like we're gonna have to do more than this, but we'll see. We're gonna have to insert a new instruction. So we're just gonna use IR insert. So how's this different from IR immediate? It isn't. IR immediate is exactly what I was about to write. It creates an IR instruction of type IR immediate. It loads it with the value. And then we insert it into the current IR and return the instruction itself, a pointer to it. Lander XD says, honestly, I probably will by the end of the month, but you know what happens when I say probably. Don't worry about it, Lander. It's okay. It's okay. We'll survive. All I care about is that you show up and you watch. That's the main concern. No, I'm just kidding. I'm just glad you enjoy it. You can do whatever you want. Saraid says, yeah, I just called it load immediate, but it's basically that. Oh, I know. I just remembered as soon as I got here, and I already wrote this, the reason this is the way that it is because we have problems immediately when we try and actually do it. Ooh. Yeah, that's a wonderful... Oh, man. That's the classic access denied. Code 5. Okay, so we have code 5, which is worrying. May have something to do with this. Oh, because we didn't change symbol address yet to be a local proper. So instead of using int64t, we're actually just going to have an IR instruction pointer, believe it or not. And this will point to the actual stack allocation instruction, or whatever, that the local is, that the local needs, right? The address is in local. Good enough. It's just an address to the instruction. Okay, so... Oh, it's more mad now. Because here, IR load local address, so we didn't rewrite those. That's okay. Block. So instead of int64 offset, it's going to be an IR instruction local. We could also call this like stack allocation or whatever, but we'll just call it local because we're loading a local. Okay. There's probably another one. What is it? Oh, now I didn't change it in the C. Load local address, which is an IR instruction local. Hey, I keep doing that. I keep alt-tabbing out of Emacs, Control-Z. Hey, now we have no warnings. No, that may just because... Didn't... What? Oh, I'm not in the right spot. I'm like, wait. Oh, assignment to instruction pointer from int64t. Yeah, that would be an issue. What's up above? What happened here? Get away. So, address... Oh, that's right. So symbol to address. So when we're actually returning a local, then we should say, this is an IR instruction, actually. Which means that, yeah. So here's the case where we have to pass an IR instruction point through a node, seemingly, through an AST node, which is not ideal. Is that correct? I think that's correct, but the only reason that's correct is because we're using an environment to try and get this thing. So we'll write a little to-do and say, make a custom local to, we'll say symbol, I guess, symbol to local instruction hash map / table. That way we can get rid of IR mention IR node type in the AST. Sure. We'll go with that. Sure. So the problem here is these are AST nodes, and we have to store an IR node, an IR instruction, in an AST node so that we can store it in the environment and stuff. Yeah, it's not going to be great. So this is going to be like instruction. Oh boy. Okay, so parser. And we're going to have a node type for it, which is going to break a lot of things. I mean, we don't technically have to have a node type for it because we've already done type checking and everything. And it's not really ever going to be in the AST. We can just not have a node type. Do we have node type invalid? We have node type none. It can have none type. That is fine with me. So all we have to do is add to the value union. And it won't even make it bigger because there's already a pointer here. How about that? And we can just say this is an IR instruction pointer, IR instruction. Instruction, IR instruction, I don't know. Hopefully that's fine. I did call it IR instruction. Soraid says, yeah, the allocate instruction is stored in the environment along with the local variable in my implementation at least. Yeah, it's the easiest way without changing a bunch of code. We could probably just heap allocate this and never free it. It's not really a big deal. Also, 1024 is expecting a very large symbol. I like the idea that this would get range to 1024 bytes. I would just love to imagine what that would look like. The symbol that someone wrote in their code. It's like, would they take their ideas from Germany? Just keep adding words together? It's a good idea, to be honest. It's better than English, where we just say, that means that, because. Soraid says, that's just in case Java programmers decide to use the language. Ooh. That was rough. I like that. I like that. Oh no. I'm sorry. I gotta do this. It's killing me a little bit. Can you also do the same thing here? Can you imagine how cursed that would be? To do return with function? Like a function call? Oh. That's just chef's kiss C code right there. Soraid says, please do not write return with parentheses. Soraid says, some people do that, and there are only downsides to it, especially in C++. That's hilarious. I can't believe that's actually a real thing. Lander XT says, Java programmers? Such a breed exists? I mean, I've only ever heard of them in tales, but I've heard, you know. So, yeah, this is no longer gonna work. So we're gonna have to create a node, which is gonna be this is gonna be like the, I don't even know what to call this. Local reference, sure. It already has type none because it's set to 0. So all we have to do, whoops. Also, I got to turn on company. Yeah, .ir instruction equals local because we already did this. So now, hey, look, we already had it to do here. And this should now function. That's good. That's closer to the code 5 that we've been wanting. Damn it. No, it's okay. If that's not it, it's probably got to be something, you know? Oh, I'm so sorry. Okay. Second argument is memory leaked. Don't worry about that. Don't worry about that. Okay, we also have to do Phi stuff. So we're gonna, okay. Did we even, I know I'm jumping around here a little bit, but if we didn't deal with that. Yeah, we didn't deal with that yet. Okay. Phi, or Phi, whatever you want to call it. It's a Greek letter. It looks like an O with an I through it. Oh god, sorry. And basically, it's just, I don't know how to describe it right now because it's early in the morning. A Phi node is just a way to represent that multiple values have to be stored in the same hardware register, or they have to end up in the same place somehow. You know what I mean? Multiple values from different control flows, generally. Lander XT says, two-step guide to not being a Java programmer. 1. Open up IntelliJ. 2. Right-click, convert to Kotlin. Soraid says, basically, yeah. Soraid in reply to Lander, Java programmers? Soraid says, I know, it's hard to believe. Soraid says, there's an explanation of Phi nodes in the register allocation docs, if I remember correctly. That's true. Basically, if you have like a block, and then you branch from it to two other blocks, right? So this would be like a then and an otherwise. And then you end up at a place where these both join back. So if you can imagine you like are in here and you say if then or if otherwise. So this would like be an if else statement. In the join, if you use a value that was assigned to in the if else statement, then you're going to have to use it outside of it again, which means it's going to have to end up as basically its own value, because it could either be not set or set based on the control flow of the program, which has a whole bunch to do with register allocation and just IRs in general. It's not too complicated. It's just basically an if statement on its head. So instead of saying, okay, this is a branch to multiple places, it's saying from multiple places this value may come, right? And what we're going to have to do is probably have like an IR Phi argument type of thing, because I'm just going to make a simple linked list. That seems like the easiest thing. Whoop. We'll just name that value. Then we're going to have an IR Phi argument pointer, which is going to be argument. Okay, so, and then what else are we going to have in the Phi node? I know we need something else. Each argument probably needs the basic block that it came from? Question mark. Sorry, it says the basically yeah was in reference to your explanation of Phi nodes. Nice. Thread says yes. So we need an IR block. Just probably a pointer. What kind of block is this? What actually is this? So this is is it the origin where the value of this argument is found? The block is the predecessor of the block that the Phi is in. Yeah. So where the argument like value is within is just this block. So if we did like value block, it would also equal just block in the Phi argument, right? Crucially, it need not be the parent of the argument. Okay. So it can just be I understand now. Because in our little game, we pretended that it was simple. But if we had like A go to T and O, and then make it to J eventually, right? If these are our basic blocks, I know this is horrible, I'm sorry. So if these are our basic blocks, the problem is O may then branch into like B. And T may just go straight to J. So then we end up with like B being this block here for the value that was set in O even. Because this is the control flow. Is that correct? It needs to be the bottom, like the closest to where the Phi node is in the join block. Though one of the control flows may assign to it an O, but then jump to B, which then jumps to where the Phi node is, which means we have to say B here instead of O, which is where value block is. I think I get that now. That makes sense. So I'm just gonna put this here and say stores the predecessor to the Phi node in the direction of the argument assignment. Oh god. That's even more confusing, but it's fine. We'll do that. Whoops. And then we'll say, for example, if value block equals O, then argument. We'll say arg, just for arg block equals B. Is this correct? Yeah, a phi argument means set the value of the phi to the argument value if the block containing the phi was reached from the argument block. I get you now. I get you now. So we only want to use this argument if this block was where we came from, control flow wise. I get it now. Thread says, so yeah, that's correct. Beautiful. Beautiful. Okay, and this is the assignment of the argument value itself. Does that make any sense? I'm just going to say this is the value of the argument itself. I could, I'm just going to keep that. And then this is obviously a linked list of arguments. Should we store the parent phi in each one? Do you think that's worth it? Or will we always have the parent phi? Also, does phi need nothing but a list of arguments? Could we just have IR phi arguments? Straight says, no, I don't think that's necessary. Cool. I'm probably missing something in IR phi, but I'm pretty sure we could just have this. We have a value, a block, and next. There's nothing that actually needs to be in the phi itself other than this. Unless I'm incorrect. Looks good to me, I'd say. Beautiful. So we're just going to use arguments in the value themselves then. Is this IR? Is this the union? This is. It looked too small. Okay, so an IR phi argument. I wonder how big all this is getting. I mean, this is just a pointer, so that's pretty good. A call is probably 16, 24 bytes. It's not the worst. It's not the worst. So an instruction is probably going to end up at like 100 bytes, like you were saying. Oh well. To do phi stuff. I like phi stuff. So I see a lot of these attach block things. Why have we not done this? Generate if instruction with then otherwise blocks. So we never even generated the branch is what it's looking like. So we generate the condition and then we say make a bunch of blocks. 3 of them. And 2 pointers, 2 created blocks. We generate an if instruction with then otherwise blocks. So then this is basically, we just have to say this. If I'm correct, I don't know. We probably don't need expression result actually, but we can just say IR branch conditional, no. And then context, IR instruction condition. See, that is where we need to use expression children result. And then we can use the then block and the otherwise block. It's good enough to me. I don't know, we'll leave it. So it says, oh dear, if code gen, here we go. Yeah, it's pretty much the best place to be, right? So if we go to IR branch conditional, we don't even have IR branch done. This is a good sign. So we'll just write these really quick. This is an IR branch, right? So we're going to need these types now. So we're going to need IR branch. I love implementing phi before branches. Okay. And okay, we're going to need IR branch conditional now. So we're going to need like a IR conditional branch, right? Because there's some stuff we need to store. Oh, just this, thanks. So what we need to store is the condition, right? We need to know what is what. What are we branching on? And then we need to store the then block. So this would be the true branch, right? And then we could have the otherwise block, which we'll call the false branch here. I think that's okay. That's probably all we need here. So now we just need to pop this bad boy in here. I've lost count of the number of times I've messed up if code gen in the past. Lol. It's one of the hardest ones, but I don't think we'll do too bad. I think we'll be okay. We'll just have a direct block reference, just a generic one to use like reference here. Let's pop it up there. Okay, so now we have a conditional branch, which is a whole bunch of things. And now we can probably set that up in here. That's right, now we can do this. What are we doing? This is just going to be block, which is going to equal destination. We're going to IR insert the branch. Insert, not isnert, and then we'll return the branch. How about that? Instruction will be a branch, but this is a branch conditional. Branch value conditional branch condition true branch equals then block false branch equals false block otherwise block. There we go. We can IR insert. Do we want to IR insert? I think we do. Context branch. Hey. We don't need load immediate if we have immediate. We discovered earlier. Compilation xdub normally with code 5. That's perfect. That's what it's been doing. So we branch the conditional, we attach then block the current function and make it active as our current block. Ooh boy. So effectively we're saying that we need some API that we don't have, right? So we should probably say, have like void IR block attach, question mark. So we're gonna have a context, a function, and etc. Rohan says, "Ah yes, code 5 always comes back." Pog. Lamau. And then an IR instruction. Nope, IR block of block. So what we're doing here with IR block attach is we're effectively taking the function and just inserting a new block at the end of the last one. So we should say basically not function last equals new block, and also function first equals new block. And we can say function perfect. That's all we need. Now, this should probably never happen because of how we create functions here. We always set first and last to a new block. So it seems like maybe it's a good idea to just not include this, but it's fine. We could, technically this isn't needed. because of how we create them. But if you created one here and then tried to attach a block, it would break. So it says, by the way, as a sanity check, I usually mark a block as closed whenever a branch instruction is inserted and assert that the current block is not closed whenever it tries to insert an instruction. Assert function last, maybe. We could. We'll just do this. We'll keep the functionality. I don't think there's a problem. In any case, so if not function last, that second assert is for IR block attach. That's what I meant. Bless. I see what you mean. So, I was thinking ahead too much. I get you now. I get you now. So effectively, we want to assert, and then we want to say function last next equals this new block function, then we just have to say, yeah, function last equals new block, right? Because we know we have the last one in the function, we only need to add to the end of the linked list. We don't need to deal with previous. I guess we need to set previous of new block. Previous. There we go. There's our little linked list swap. And that should be it, but except it's not. Right? Because we have to set function, the context insert block, we should probably update as well. But we only want to do that if this function is the one function. So how about this? Attach to current. Function equals context function. Then we can just say context block equals function last, which is actually this new block. I think that's the way to go. I think that's the way to go. Also, Sarade, thank you. This is much cleaner. Could also like assert context and say cannot attach block to null context, and then we can also assert new block. Say cannot attach null block to context. We should probably also assert function. A lot of things are assumed. It doesn't matter. Do you really want to put assert context everywhere? I mean, there's null checks everywhere. I don't think it's a big deal. You know what I mean? There's such a thing as too many asserts, you know. Then we'll just we'll start doing this. If not context, return. Is that better for you? We can do this as well. We'll just assert everything. We'll assert that function exists, right? We wouldn't want to do anything, right? Assert it all. Well, that's even worse, lol. Exactly. But you're right. We probably don't need that. It's probably likely that we could get a null new block, though, if we screw things up. I mean, it's very rare, so we probably don't even need it, because we're always going to use IR block create, which should not return null unless things are going very, very badly, in which case we screwed up elsewhere. But you're right, that was too many asserts. I was just joking around. It is nice to write code like that, but then it's like, it's not nice to have to go and change anything or add a new argument or do anything. So IR block attach to the current context and the current function, and then make it active as our current block, which is also going to do the same thing. Okay. And this is going to be our new block, which is going to be our then block. This has to be a code gen context. Okie doke. Should be another one of these. Attach otherwise block. Wonder how much would break if you tried to attach the same block twice. Ooh. I just realized that would harm a lot. Ooh. Yeah, that's no good. Don't attach the same block twice. Everything will break. Everything will break. Attach a join block. Okay. Did I not? Okay. Phi step. So we're going to have to create a phi, which is the return value of the if expression, right? This is what this represents, I would presume. Sorry, it says yes. So we know that the return value in our language of a block is determined by the last expression in the block. So the last instruction in the block should hold the return value. So all we have to do is keep track and say, from the last otherwise block, last instruction, because we have branch instruction, which hopefully is separate. But it's not. We didn't write it that way. Currently. We just wrote IR branch, which inserts. But we should probably, again, do the closed thing. So this is the last instruction, right? Otherwise, return value. That's assuming that the last instruction in the block returns a value. Oof, you're correct. So that's not right. So the problem is, which may or may not always be the case, that's correct. So how do we keep track of the... This is why I hate if code gen. It doesn't matter. So, I mean, we can do that in any case. So we'll just say the last expression in the block has to return a value. I mean, it doesn't... I don't think that's too crazy. Because then we could even enforce more stuff about that in the parser and the type checker in the future, right? And have like if then bodies. They're already type checked to make sure they return the same value, so it's kind of already done. I'd say if the last instruction doesn't return a value, it's just void or no value or something. It'll just be an IR immediate 0. It'll be this, right? But yeah, that should maybe go in the type checker. Yeah, we should just make sure ifs never get to the IR in this state, get to code gen, which I think is doable. So I'm just going to mention this. This assumes that the last instruction in a block returns a value. If it doesn't, we will simply use return 0. I think that's fine. For now. This should probably be ensured in the type checker in the future. In the past, like before we get to this point in control flow, but in the future, because I'm not doing it right now. IR5. So now we need to create a phi node, which is going to have, oh boy, what are we going to need? We need the context. What do we need? We're going to need the context, and we're going to need, and then we're going to have a way to add an argument. We're going to have like, and this one's going to have a phi node. Probably a context. Okay, and then what else are we going to need for the phi? We don't really need much, do we? We don't need anything until it creates arguments. Okay, so IR phi argument and IR phi. So phi argument is like when we want to add something. So we need to have like IR instruction equals IR phi, but then we're going to have to insert the phi at a later date. Unless we want to pass all of the arguments here, which I don't think we do. Right? So we're going to need something like this. Yep. And then we're going to have to do IR phi argument. So IR phi, this should not insert the phi node. That needs to be handled after arguments are added. The phi goes in the join block, which I'm assuming is the block after then else. It's true. Oh, true, so we could just insert it. And then add the arguments to it. So it can insert. Because we can add arguments to the phi node after we insert to it. Also, adding an argument to a phi doesn't generate an instruction. Yeah, that's what I was just realizing was wrong with my logic. I was like, wait, how's this gonna work if the arguments get inserted after? And then I'm like, gracefully reminded by Sarade, you're an idiot. Phi arguments are just pointers to existing instructions. They don't generate anything. So we can just do them like this. Wonderful. We probably don't even need the context, but we are going to need the argument. Okay. How about that? How about that? So we're going to need the otherwise return value. And then the phi argument's also going to need a block, right? So we're going to have like the block, which is the predecessor. Sure. Sure. And this is going to be the last otherwise block or whatever. I think that's how that would work. So IR phi can absolutely add a thing. You're going to have to go implement these. I don't know. Here. Oh, this is a mess. Okay. This is a right mess. So if phi already has, did I not add it as a into the value? That's pretty embarrassing. Oh, I did. It's just an IR phi argument. So it would be argument, which is probably a bad name. Phi argument. So we're going to go with if phi argument else. So if it doesn't exist, we can just set this to a new phi argument, right? So either way, we're going to have this new structure. This is going to be argument, which is going to equal calc 1 size of IR phi. No? And this is going to be phi argument. Sure. Lots of everything is named the same. So then phi argument, we're going to set up with the block of the phi predecessor and the instruction, its value equals the argument, right? Then we can just add this phi argument to the linked list, which means we can either just add it to the beginning or do some shuffling around and add it to the beginning. So we can do phi argument next equals phi argument, and then set phi argument to this one, which means when we follow this linked list, we'll get the rest of the linked list that was here before. Also, that's almost really bad. There we go. I think this makes sense. Let's go over it. So we create a new phi argument and set its data or whatever. And then we say, okay, if the phi instruction we were given has a phi argument already, then set our current new phi argument to the existing phi argument. We could probably do this in any case. Like, there's nothing being dereferenced here that's bad, is there? I don't think so. We can probably just do this and not worry. Am I wrong? Just add to the beginning of the linked list. Because even if this is null, we never then go on to dereference this. We just set it to assign the value of it to next. I think this is fine. This, however, when we create a phi, it's going to be interesting. So we don't have to do anything. This is the weird part. We just have to wait for them to add phi arguments. Also, we don't need the context, I don't think. How about that? How about that? I think this is somewhat gonna work. I could be completely wrong, but I think it may. We'll get the then and the otherwise. Last instruction, we'll add them to the phi arg. The phi arg has been inserted within the join block. Or result of if expression in join block. I think everything looks good. So let's see that code 5 once again. Beautiful. We love it. We love it around here. And we're going to hope that this works. How about that? I'm sure it doesn't. I'm sure it doesn't. Let's try and figure out. We're going to use the devil's lettuce. I mean, the devil's IDE. And try and figure this out. Visual Studio. Again, we could use GDB. I'm just lazy. And on Windows. Okay. Alrighty. I think we're ready to switch over. And let's figure out what it's trying to run. Sir Hade says, wait, what happened? I wasn't paying attention. I was busy doing calculus. Well, that's your fault. No, I'm just kidding. What happened is not much. We effectively just are hunting down the code 5. I think we're done with if code gen. I think we did everything correct. We have everything in the correct order, generating branches in the join for branches to the join for both then and otherwise. And now, we'll get there. Yeah. Hey. The neighbors upstairs are being loud. So when we're trying to insert, it says context block last instruction was null putter. That makes sense. That actually makes a lot of sense, because when we create a new block, we set its branch to the first instruction, which is just a return. Also, let's fix that. Let's fix that. So instead of creating a return right away, we're gonna leave the block branch as null. Okay. Oh, VMe says huzzah! What's going on? What's going on? What's good, VMe? How's it going? Sir Aid says, oh yes, seg fault in the if code gen sounds familiar. Oh, we already have the closed marker. We just don't set it. So context block closed. Context block closed. Wonder if we could just have like is branch instruction and then say if is branch instruction in IR insert, then close it. Hey, oh damn. Ropa McCad raiding with a party of 24. Thank you so much. VVAC says, you got a raid. First time chat from Are you a compiler? VVAC says, we got visitors. First time chat from Ropa McCad, the raider himself. Thank you so much, Ropa McCad. Be sure everyone that was watching me before, go check out Ropa McCad. I'm sure he's dope. He says, hey, would hang around, but I gotta run. Compiler sounds like a fun project. Enjoy. Thank you so much, Ropa McCad. Have a fun time, and thank you for the amazing, amazing donation of viewers. GCB Aku says, show linter. What? Vimi says, sorry, I won't be terribly active today. Followed up immediately by, raid! Vimi, the duality of man, truthfully. Hey, GCB Aku and Anuraganan 789. 7 did? Thank you so much for the follows. Arusia says you can make your compiler make noises when it compiles successfully or with an error kappa, in case you want to annoy your neighbors back. I should just make it turn on like the loudest speakers I have, point them upwards. Gizba Aku says, how do you read your code? Generally left to right, top down. How about you? No, I don't know. Because I know what I'm talking about. It's just, I'm within the context of the code, so everything makes sense. Gizapu says, no, from the string file. What? Vimi says, what are you doing, step class? Wait, I know where that's from. So when they're closed, so then in IR insert, when we insert a new block, or instruction, excuse me, then we can just assert that the context block, first of all, exists, and it is not closed. And then say, cannot insert into a null, no, into a closed IR block. Perfect. We could also just say, if the branch does not equal null, right? We don't necessarily need this extra thing. Let's do it. We're going to do this. We're going to try it. So assert that branch equals null. Yeah. There we go. I forget. Asserts. Vimi says top to bottom. Ooh. Arusia says, I think the question is, how does the compiler read files? Ah, Gizupa Aku then points up. I see now, I see now. I see now. Vimi, kappa, kappa, kappa. Saraid says, yeah, that's a good idea. I'm glad. Saraid is the resident genius. We ask him all our horribly complicated questions, and he can answer them very quickly. I should say they. So how the compiler reads files, let's go into that. There's entire documents on it. So like if you do want to check it out in the GitHub, there's literally a developer's manual, and you can check out exactly how lexing and parsing works. There's like entire pages and pages on the lexing and parsing. But for a quick explanation right now, just for you, in the parser, we have a lexer, and it basically just opens a file with fopen. Right? You get a file pointer with fopen, and then you just say file pointer my file equals fopen, and then you open it for reading, right? And then you say code dot, right? Whatever the name of the file is. Source code. Why not? And then with that file, you basically just say read all of it into a string, right? And currently, that's what we do. We're going to eventually set it up where the lexer can advance like the current position within the file, but currently we just have one big string of source code. It's not really the best, but it does work, and we lex. But yeah, eventually all we have to do is make it so lex like tries to lex, and then if it fails because we reach the end, then we try and read further in the current file, and then we try and do it again. And there's a lot of stuff to get to, right? Saraid says he is fine, haha. That's awesome. I just never have asked, and I always worry in 2022. Yeah, basically, we read files and then split them up into tokens. We just read them as one big string for now. But eventually we'll make it so if we get to the end of the string, we check if there's more in the file and then get there. And only read like 4 kilobytes of a file at a time. But nobody's writing 4 kilobyte files in this language yet. So that's a good sign, ain't it? We're going to be okay. So this is our linked list. So when we do IR branch, we don't actually want to really insert it. We just want to set context block branch equal to branch. Because it doesn't need to be an instruction. It just needs to say, hey, this block branches to here. And then we'll handle this specifically. This is going to be fun. Branch. We're also going to need IR return, are we not? We are. I'll just write it now. You know you're at a certain point in refactoring when you're like, I'll just do it all right now. So we have context, which we only need to get to the block. I can't call it return. Ooh, that's mad. Okay, instruction branch of an IR return type. Doesn't need to, there's no value to do with anything. So this should be good. Probably do like that. Do it like that. Do it like that. We're not gonna need the 0 anymore. Don't think this would make any sense anymore in the IR. This is just remnants from when this used to be CodeGen. We can just repurpose this one. We are going to need to copy values and stuff. Okay. I'm done getting distracted now. I'm done getting distracted. I'm going to go put this in the header before I forget, though. Yoink. Perfect. Let's try and build it. Perfect. Exited with code 5. That's always the best. So last instruction is probably still null. So when we insert to a block, we have to handle the fact that the last instruction may be null. In which case, we can't say the next to the new instruction. So we just basically have to say if we'll do all this, but only if context block last instruction, right? Probably do this either way. Else, yeah, probably do this either way. Well, that's the thing. It's going to be different. It's going to be different because in this one, we have to set last instruction to the new instruction, and that's it. Right? This is kind of all we have to do because there's no previous. So really we can just plop this here. I know that was a lot of refactoring. I think that's fine. So basically, if this context in the current block has a last instruction, then say the next to the last instruction is this new instruction. Then the new instruction has one previous to it because it's the last one. And the last one is the one previous. That's what this little diagram is supposed to show. And then no matter what, we set the last instruction to the new instruction, which means even if this doesn't exist, we'll just update and say, hey, now last instruction is no longer it. But we probably want to keep track of it more than that. Do we want to say, see, we have instructions. So when we get to our first instruction, we also want to set this. So we should say, this isn't the most efficient. There's definitely a better control flow to handle this. But if not context block instructions, right? Then what we can do, not context block instructions, is basically set it to the new instruction. And then also set the last instruction to it. and then return, right? I mean, and that's kind of all we need to do. Is there anything else? We have next, predecessor, previous, branch. Does that make any sense? Then we never have to check if this is if, because it shouldn't happen. I mean, we should. See, it sucks having a beginning and an end, because we have to check both of them. So if the beginning doesn't exist, set the beginning and the end. If the end doesn't exist, just add to the end, which doesn't really make sense because we would have to add to the beginning. So I think I can just leave it how it was. This now saves us from having to deal with it. Hey, look, it did. It worked. We now get all the way to IR add. That's a good sign. And that's this to do right here. All we have to do is say IR insert into the context, the add, after creating the add instruction. I think we're just going to do it like this, by the way. These are in the worst order possible. Okay. By the way, if anybody has any questions, let me know. I love answering questions. And that's not facetious. It is truthful. Ask anyone here. I truthfully enjoy answering. I go on long tangents answering questions. Because it's fun. So we're going to have a new structure for the IR instructions that we're implementing, because we're going to need to store a left-hand side and a right-hand side. So we're going to need like a binary tree type of thing. We could just have IRB tree. Binary tree. We're going to go with pair. I can't spell, but we're going to go with pair. And then this is just going to have an instruction on the left, an instruction on the right. Should name them car and cooter. And effectively, all we have to do is say that we're also going to have to keep track. Well, I guess the IR instruction type will keep track of what type of instruction it is. So when it references to, we can just say create a pair. Then we're going to have to put this pair within the IR value union. Good enough for me. So now we can say add value pair. And then we can say the car is the left and the cooter is the right. Hey. First time chat from Brian K. Or maybe I'm wrong about what editor this is. Maybe I missed a chat earlier. I don't think I did. I think only one of yours came through on my end. I'm sorry about that, Brian K. This is Emacs. So if you're asking what editor this is Emacs. And it is glorious. Daddy Stallman. GNU Emacs. So we create the instruction, we set up its value, and then we insert it into the current block. Vivac says, wait, it's Emacs? Yeah, this is Emacs. IR set return value. Huh. When is that being called? By Cogen, I presume. Do we need to call this? To just set it to the last expression result? Brian K says, weird, my first attempted message was, I didn't know you can view PDFs in Vim. Yeah, Twitch is all sorts of fucked up. Vivac says, I was sure it was Vim. Lol. With the lol. Emote? Beautiful, beautiful. Yeah, this ain't Vim. This is Emacs, baby. I think I can... Oh, that's the wrong one. I always forget what button it is. I always hit it on accident all the time. And it takes me to the GNU, the main page, but I never know how to get there on purpose. I'm sure it's some command I can run. But yeah, this is entirely Emacs. This is free and open source, baby. And it's also, all my configuration files are available on my GitHub. I wrote this theme myself, and I wrote a bunch of the things I'm using down here myself as well. Saraid says, you can view PDFs in Vim, but it's not going to display anything useful. Yeah, it'll look like, what? I don't remember how to do it. Yeah, this. You can do it in Emacs as well. This is what it'll look like. Rusius says there's MX version, which will tell you which Emacs you're running exactly. Ooh, that's true. I'm running 2905. No, 28.1. My 2905 is on my laptop. That's right. I built it just recently. Because that's their most recent release. But 28.1 on the desktop from NGW. Beautiful. Build from April a year ago. I gotta update my builds. But yeah, this is what a PDF looks like in Vim. It's not as helpful. Emacs has a little bit better PDF viewer, I would say. I don't know why it's not in the center now. That's funny. Hey. Okay. So when we set the return value, I mean, it's fine. We can do this. So we really just need to say an IR function. Whoops. I mean, it already has return value. So we just need to set its return value. I now understand what we are doing. Why can't we just do that? Yeah. You know? I think this is plenty. I don't think we need a whole function to deal with it. We did before. But no longer. How beautiful is that? Oh, good. Undefined reference to IR set return value. Where else do we use it? For the main function. I get it now. I was like, wait, what function don't we generate? Oh, it pretended it worked. Let's check out the code it generated. Ah, yes. Beautiful, beautiful assembly. What happened there? Well, we got through it. Now we just have to say codegen emit. We may not have written yet, which is a slight problem. It's okay. We can then go into codegen. I mean, it's going to have to be in codegen forward. Where is this going to be? It's just going to be in the codegen file, is what I've just decided. Because it doesn't really make sense to go anywhere else. It's just going to be a void for now. And we'll take in codegen context, pointer context. And we'll say basically, switch on context format. That's the biggest one. Say default to do handle blah, blah, code generation format. Feeded our format. And then in the case of a recognized format, as in gas, then we can say codegen emit x86-64 and codegen x86-64. So yeah. So now we've included the arch here so that we can generate code with it. I think that's somewhat sensible. There we go. Now we're trying to emit code. Crazy. We're already there. Isn't that amazing? Vivek says, the good old, always accidentally doing it, but never knowing how to do it when you need to. Yeah, you get it. You get it. Oh. Okay, so we could either start working on codegen or start making our IR a little more better. I'm gonna be more better. That way we can kind of just get a lot of it done. So we still haven't done, hey look, a little more code. little more code popped out. How beautiful. So is that in Cogent x86-64 now? Where that's coming from? Where is this coming from? I don't know where this is coming from. Probably not the right place then. Oh no. Oh no. Yeah. We're still doing fprintf in Cogent program. This is bad. Yeah, we have a to-do here saying exactly this. We're just gonna yoink this and put it not there. Should go here. How about that? How do you... oh, you just don't believe in me. I promise, there's an error. We could probably just assert 0 here, or assert error.type, but I don't care. This is fine for now. The reason I'm not right now is because we may actually need to know what these errors are. So I'm going to print them out in case we run into them. Sorry, it says panic. Yeah, that's not a bad idea. I just want to be able to print these out. That's basically assert 0. True. So we could say if error.type panic. I like it. I see. I see where you're getting at. Not just basically, it is assert 0. You're correct. So, yep, we still have some stuff to do. But overall, global variable should now not be generated for every single backend in the same way. That's beautiful. So now IR load local. We're not going to need into anymore. At least in this scenario. So this will be an instruction of a local load. IR local. Should I group them by local and global, or should I group them by load and store? Because I could either do IR load local, IR load global, or I could do IR global load, IR global store, etc. I think I'm going to put that first. I'm going to do like this. I'd maybe write a function that dumps the IR first, just to see if it's generating it correctly once the IR is done, that is. At least that's what I'd recommend. Oh, yeah. I think we already wrote those. All we have to do is actually use them. So will this be a local load? So local load value. See, this isn't going to work anymore in this way. We're going to need a pointer to the local to load. Every time, Assert. Every time. I think that makes sense. Also, text formatting on Twitch is lacking. Yeah, it sucks. I don't know why they don't like include Markdown in their Twitch chat. It's like GitHub, though. They're also not... it's like they barely support Markdown. It's really funny. So this is no longer offset. It's local. Okay. So in codegen.c, before we emit it, we'll do IR emit, right? Is that what we called it? IR f emit? And then we'll just put it to standard out. IR comparison. Ooh, let's do a simpler one. Let's just go back to simple math and hope it's correct. Perfect. IRF emit has a to-do in it. Lamau. We didn't write them. We got nearly there. we did fmit instruction with one case handled. Let's do that now. So ir block. So we're going to say block branch is something we have to print out. And then we're also going to have to do for every instruction, block instructions, instruction. And instruction equals instruction next. Okay, so then we can ir fmit instruction. File. Okay. Omit all the instructions and print out something like basic block blah. So we didn't give block an ID, which is a mistake. Let's give it a size T ID. IR block. Unique ID among blocks. Sure. Sure. What's wrong with the 4? Why are you mad at me? Oh, you're not. It's just a semicolon. Gonna need a new line. Arusia says Twitch chat is just a bunch of extensions to IRC, and I'm guessing no one wants to work on that end. Lol. Soraid says, that reminds me of that one time when I was watching a stream and the chat program they were using was susceptible to HTML injection. Oh lord. Soraid says, XSS go burr, basically. Cross-site scripting. Soraid says, Lamau. They were debated, it's true. It is true. So we print that this is a basic block. We'll give it 2 levels of indent. We'll print that this is a function, which also I'm assuming doesn't have an ID yet. Unique ID among functions. And we're basically going to have the same exact things here, except it's going to be... Here, I could probably even just do this. Instruction block. Pretty close. Okay, then we would like to ir fmit instruction actually for the function return value. Okie doke, okie doke. Vivek says in HTML tags, interesting, in HTML bold. Sorry, it says, yeah, that, except H1 style and marquee, and pretty much everything else also worked. Oh lord. Those are the 3 I remember. That's crazy. Okay. So now to fmit the context, we just want to say, we could print a title. Well, we won't print a title. We'll just say for ir function pointer function equals context function. Shouldn't we have like the first function somewhere in here? Yeah, we're gonna need to store that. Otherwise, we're not gonna be able to go through all of the functions, right? So we're gonna need all the functions in the codegen context. So we're going to need an IR function pointer, which is all functions. Sure. And then function equals function next. So it says, it did manage to sanitize script tags, but not attributes such as onload. Also, I just tried to write script tag in brackets, and Twitch wouldn't let me. Well, they don't even allow it. They're like, nah, we won't risk it. Yeah. Ooh. Wouldn't let him do script. Amazing. I put screenshot in general. Yes. Okie dokes. Now we emit all the functions. Everything should be hunky-dory. Wonder where that saying came from. Emit code. Hey, we made it all the way through. That means we should have printed it out, and we most certainly did not. So all functions must be null, because in here, we should say if context all functions. If it's not, that is, then set it to this new function that we've created. I don't think that's too crazy. Hey, look, white space. Huh. I have a feeling this may be going badly. Ooh, that was rough. Almost killed Emacs. Arusia says, how about and LT semicolon space script? Ooh, trying to get around it. Still won't work, still won't work. The HTML elements do not pass through either. So we now have a problem in IRF emit slightly. I kind of just want to set a breakpoint and see what happens, but so for every function, print to the file. For every block, print to the file. And for a single femit instruction, we say snprintf into null of the ID format just to get us our size, how long the ID is. So the difference we then print spaces for. Ah, we never subtract anything from the difference. How about that? That's better. Lol. Okay, and then in IRF emit, we're going to put in like some new lines. And in CodeGen, we should probably set IDs. Just so we get some numbers that make sense. There we go. Look at us. We now have 4 and 4 as two values, and then we get an assertion fail because we need to handle IR type 7 in the printout. Add. Okay. So in intermediate representation and femit instruction, we simply have to say add. It's IR add. And in this case, we would actually like to just say, I mean, it's not much different. We want to say add of two things, right? Is it ZU? I don't know if it's ZU. Probably is ZU because it's the ID. So we basically just say add has two children in car and cooter. So we can just use car ID and cooter ID. Not bad. That's add. And then it still says handle IR type 7. That's because I didn't add a break. Amazing. Hey. What happened? Exited abnormally with code 5. That's a good sign. That's a good sign. I heard that's good luck for a C programmer. Okay. Okay. So, I'm not sure what the issue is now. We're going back. Arusius says break. We have a break. And it says instruction was null pointer. So we're trying to emit a null instruction. That's the problem. We'll just assert that so we can catch that in the future easier. Cannot insert null instruction because we do a whole lot of dereferencing of the instruction. So it looks like the branch of the basic block does not exist. Just a little spook. So there's probably no branch to the main function being created, or return from the main function being created. So we'll just say wherever the main function is, cogent program. We set the return value here, but we'd like to set the branch in the last one. See, why is there no branch? I'm not certain. So if we said main last branch, if not main last branch, just insert a return, please. And then instruction branch main last branch equals branch. That should be in codegen function. You right. We're still going to need it here, but you're right. Codegen function is also going to need it. So codegen function at the end of it, we set the return value, which is all great, but we need to actually create a branch away from it as well as a return. Now, unhandled IR type 2, I bet you that is return. Nice, right back to exiting with code 5. That was my fault. I didn't add the break. Add 5 and 6 got printed twice. That's an interesting one. So when we print the return value, all we really should say, I just want to omit the ID, right? Yeah, I'll just do it by hand. And I'll say return value. Sure. By the way, if you check my IR branch, this is Serraid. There's a static assert macro there that you can use for the switch statements in case you're interested. I am very mildly interested. You may have to check that out. Is it basically just a pass through to static assert? This one? Is this the one? I think that's it. I can't remember. Yeah, I probably don't even have it included though. Nice. With an if def. Ooh, those are always the best. Do all functions have a return value in your IR? I mean, sort of. Let's think about it. Let's answer your question. So in CodeGen, when we make a function, we set the return value to the last expression's result. So every function in the IR has a return value, yeah. There's at least something there that acts as a return value. Mainly just for register allocation, so we know where to put this in case it does return a value. But if a function doesn't return a value, it's not a big deal to have this point to the last expression, right? It'll just have register allocation do something it doesn't necessarily need to. So right, it says underscore static underscore assert is a keyword, no include needed. It's in error.h, I believe, and it's like 4 lines of code, I think. Nice. Static assert, that is. Yes. Yes. But yeah, Arusius, all functions do have a return value. But it's just pertaining to the last instruction within their body. If that makes sense? So like if you said if 0 and then had like stuff and then a, right? This is horribly formatted. Sure. And then else. Come on. Why you gotta do me like this, see? Right, so if you had like stuff and then A and then B, it basically the return value of each one of these blocks would be A and B. But if this were in a function, then the return value would be the if itself. I don't know. It's just a way to keep track of things. It's not necessarily needed or corresponds to the actual return value. So it says I can also just paste it in here real quick if you're interested. We're good. We'll go with runtime asserts. We can go through and do static asserts if we want to. But I'm okay with runtime asserting things that don't change. Because we're not like, we don't need performance right now. You know what I mean? We may in the future, but right now we are rocking good. We can literally rebuild the entire compiler. I'm doing clean first. Rebuild, recompile, compile a source code, generate IR. Like we're doing all of it in like a quarter of a second. So it says it's not really about performance. What's it about? It's just an assert. There's not really much difference, is there? One happens at compile time, one happens at runtime. I mean, it means that the static asserts, you would catch them even if you don't run the program, even if you just compile it. But I don't think anybody just compiles programs to catch errors. Usually you compile and run, and that's your loop. Rusia says, as long as the macro doesn't contain any HTML, debated. Wow. Static asserts make development easier because they're compile time errors. That way you can go through and fix them all at once. That's valid. That's definitely valid. I've never just compiled a program. Every time I like write a compilation command, I always also run it. So it's, for me, an interesting one. But you're correct that we'd catch more cases that we don't hit during the runtime at compile time. It would say, hey, you got to fix this, 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 and this. And it would just list them. And there'd be no latent errors. This is working now. I think that does it. Basic blocks, not quite yet. Did I do this in the wrong one? Who knows? Who knows? Serraid, in response to Arusius, as long as the macro doesn't contain any HTML. Is that a challenge? That has real and my axe vibes. Lamau. Okay, so function 1 has a return value of 7. Cool. Cool, cool. This is all looking correct. So 1 and 2 are immediate loads of immediate loads. That sounds gross. Immediate loads of 4, the number 4. I'm going to put a dollar in front of it. So it says, I think that looks right. Awesome. So we load 4, we load 4. We add 1 and 2 together. So 1 and 2, 4 and 4. We add together and store it in 3. So you can see that each of these now are a temporary or a value. And this is how we get to our static single assignment form. How beautiful. So now 4 is another 4. 5 is out of 3 and 4. So whatever we added together and 4, that looks perfect. And then 6 and 7 are the same. So we take 4 and 4, add them together, add 4, and then return that value from main. Hey. Saraid says, you know, I'm not a fan of the function-like syntax of the instructions, but the pipe is a nice touch. Hey, bless. I just kept getting confused that, like, these are just IDs. They have nothing to do with what the instruction is, what it refers to, or anything. They're just numbers so that they help us out, which is confusing. To me, $4 now looks like it's hex. It can be. It doesn't really matter. This is just debug representation, baby. We don't really need $1. If you're okay with just having 4s. Or we could do, like, immediate and put a parentheses around it, right? How about that? This would make Saraid very mad. Saraid says yeet the dollar. Okay, we yeeted the dollar. How is it now? Everything good? Immediate IMM is definitely the chaotic evil option. That's why I'm sitting here laughing like Pepe. Also, Brian K and Myvar with the follows. Thank you so much for them follows. We're at 149, one away from that glorious 150. I can't believe Twitch is so far behind YouTube. You guys gotta start doing better. No, I'm just kidding. But it's crazy to me that on YouTube I have like 500 subscribers. I'm not bragging. I'm just saying that I only stream on Twitch. This is my main thing. I stream on Twitch and I talk to people on Twitch. And then YouTube is like, yeah, and we'll showcase your 6-hour live streams to like thousands of people. It's like, this doesn't make much sense. YouTube wants me to continue streaming on Twitch, it seems. It's a collusion of the devils. Saraid says, see, I prefer add %1, %2 because IR to me is more of an assembly language. True, that's definitely doable. So we could, not different. Just missing parentheses. What if we had no comma? How about that? Ooh, what if it was like Lisp and the parentheses go on the outside? That's like the best, right? Oh god, no, not Lisp. I snuck it in there. Saraid says, saw that coming. Lamau, you probably did. With me. Okay, I'm really happy this is working. So now all we have to do is actually do things. How about that? Let's try and do code.s. Give us greatest common denominator. IR comparison. How beautiful. I think we're literally just gonna have like that. We're gonna have to go create it. So IR comparison is gonna be what? We're gonna need the condition. So So we're going to need like an comparison type. Is that what it's called? I don't even remember. Zoraid says, I like the comma. Arusius says, no comma looks cleanest in my opinion. Ooh. Here's what we'll do. We'll go no comma, and we'll see how it goes. Because we're going to have things with a lot of... well, we're going to keep the comma. Because we're going to have like phi with an... or function calls, which can have any amount of things. I don't know. We'll see. We'll see. I like Arusius, though. I do think it does look very... Whoops. I think it looks very clean. And then this is going to have to be an IR pair. Right? I think that's how this will work. Comparison. Okay, then in IR comparison. So it says that's what I used in the IR docs. Oh, talking about the phi formatting. Yeah, I don't know about that phi formatting. That's a little sketch. It's hard for me. We're reusing helper structs? Is this C++ already? Lamau. It's true, though. Oops. Almost went bad. Should make like an insert macro, which like doesn't take in the context. Just says insert CC. Like that. That would be really easy and it's probably worth it. We're gonna do it. Where did I define instruction? Somewhere. Apparently in the header? Oh, that's cursed. Perfect. We'll do it here then too. No, we shouldn't, because it's really only for use within these functions. We should keep it in the C file. Instruction. And then we're just going to have it be IR insert context instruction. How about that? How about that? I think that makes sense. Sorry, it says, yeah, that. Nice. I think that's better. I still type Isnert, though. That's still an issue. That's a me thing. King Buns says, hello. What's up, King Buns? How's it going? Nice name. It is good to see you again. Should we insert the branch? I don't think we should insert the branch. That's what all this was about. We're just going to go through and change everything. There we go. In function IR internal call. So it's going to be an instruction, which is a call, which is an IR call. It's going to have a call value call. We're going to need a type. Oh boy. This is becoming one of the messiest structs in the world. So with this enum, we want either internal or external. We'll default to external because why not? And then we'll say count. And these are going to be IR call type. Cool. So now we have an IR call with an IR call type, a value, which is what? Like what can be called. Okay. So this is effectively external, internal, same as here. External, internal, hence the union. And then we have the arguments, which are all the arguments to the function call. So type equals IR call type internal. Call.value equals function. Shouldn't that be a function? We'll see. Sorade says, I think you're starting to realize how the abomination that is value came about. Absolutely. King Bun says, just back from nomading around in the mountains was quite nice to end the summer with. Yeah, that sounds badass. Holy crap. How was it, King Buns? It sounds amazing. Rusia says, could call it push instead of insert if that's easier to type. True. True. Get rid of that isnert. Sorate says, also, rather than internal and external, I'd suggest maybe indirect and direct, because that's effectively what the difference is, because the calling convention is going to be the same eventually. Yeah. Yeah. Just do define isner insert, lol. Oh no. Curse. So, is this how we're talking about it? Is external is direct? So this would be an indirect because we load the value. Sorade says, I literally have alias Claire equals clear. Lol. External equals direct, internal equals indirect, yeah. Nice, because we have to load the function address and then jump to it. Or that we don't have to, but that is what we do. So for an internal call, that should be it. For an external call, ooh, look, copy and paste. It's just direct. I don't care. I don't care. Perfect. What do we got? Load global address. Simple. What do we have here? Passing argument to discards const qualifier. I don't quite care. Sorry, it says, and maybe rename the function too. That's probably a good point. Wonder if it'll work. Did it do it in the header as well? It did. IR direct call. Yeah, we'll see. Sorade says RIP const. It's so much work to have const. Undefined reference to internal, external. That was easy. So they probably shouldn't insert themselves, huh? I mean, we can add arguments. It doesn't matter. It's fine. Whoops. Perfect. Exited with code 5. Let's see if we can't go figure it out. Simple math should work. Gotta love the worst debugger in the world. Just the worst way to set settings. If it wasn't so bad, like there's a million things on the screen and a million fucking menus that all have shit in it, everything would be fine. It says arguments was null pointer. Yeah, I think that's the point. Okay, so to add a function call, or add an argument to a function call, we would like to say, basically, if not arguments, arguments equals blah, else. Look at that. Now just saying IR subtract is something we need. Which is, it's just going to be this. It literally is just going to be this. But guess what? It's not called add, it's called sub. Crazy. Okay, so now here. Subtract. Why not? Hostman says, good evening. What's up, Hostman? Thank you for tuning in. How's it going? Yeet. We don't need these. Yeet. Okay. Hashtag define const to nothing is actually pretty pog, Arusius. Just this. Ooh. This would be beautiful. You'd never have to worry about const correctness again. Is there a reason you have different IR type cases for add sub mul but only one for comparison? No. We could just as well have like an IR math or IR operator or operation, and then have IR operation type, right? It's really not a big deal. But yeah, we could totally also split these up. It doesn't matter. You are correct, Arusius. We have one comparison, but we have many maths, arithmetic operations. So to load a global, we basically just want to say create a global load. So what global are we going to want? Right? So we just need a string. We just need to store the name. Sure. We'll just have a string. Why not? Value. Okay. Why not? Saraid says that has the same energy as hashtag define true false. Not really. You just never have to deal with const correctness. I think it's pretty awesome. Saraid says, you know, at some point I'm going to open a PR and the title is just going to be add const in 274 places. It's not needed though. Arusia says, I think someone did that for the Linux kernel once. More than once, I bet. Haha, says Saraid. Arusia says, but over the course of years, not just one PR. As the Linux kernel does. That's their style, over the course of years. Load global address. So This is like a reference, right? Because we can have load store, but we can also have a reference to get its address. We could just call it address. That's fine. All right. Woo! Might as well do the same thing while we're here. Woo! Going at lightning speed, everybody. This is going well. I think all these look good. Yeah. IR store global. Classic. Okay, so instruction. Local store. IR local store. Local store value dot. Oh, this is going to be a lot of things. I'm getting rid of const now just out of spite, by the way. It really just because I can. So this is going to be a whole thing. Right? Because we're going to need a string and an instruction together, which is not something we have already. There's gotta be a better way to do this, man. I wonder if it would be more efficient to just have a bunch of unions, where like comparison, we just have like 3 instructions. I don't know. Like instead of having one big union with everything in it, could we just have a big struct with a bunch of unions in it and just reuse the different unions for different things? There is a better way of doing this. It's called inheritance. I don't think it would be any cleaner with inheritance. You go write it in C++ and show me how clean it is. One of the few instances where that's actually useful. I don't know. How would inheritance help any of this? You still just need all these different pairs of types. I have. Look at my compiler. It takes up less space. That doesn't mean it's cleaner. It just means there's less text or less code to define it. Cleaner would be like understandable, right? Readable, where you have like A equals B, B equals C. Everyone would agree that that's clean because there's nothing wrong with it. It's understandable. But as soon as you start going like, you start really messing with it, it starts getting less and less understandable and less clean, right? I don't know. Sorade says, yeah, it's not cleaner because there's no clean way of doing that in either C or C++. I would argue there is. Because we reference, for example, instructions a lot. So if we just had a struct with 4 instructions, but they could be named different things, then we could only have like one set of instructions that we ever reference in every single instruction itself. But they mean different things and are named different things. Because you could have like our instruction pointer, left-hand side, but then this would be part of a union, which is also called IR instruction pointer reference, right? And then you would have another union, which is like right-hand side, but it could also be something for like global assignment value or something like that. And then this union could also have char pointer, and you could basically have as many unions as you need children of IR instructions in some level. There's a compiler called neatcc, and I think it has something like struct IR code long operator 1 A1 A2 A3, which is pretty much exactly what I'm talking about. And the A1 A2 A3 fields just mean different things. Yeah, I mean, look at my IR branch. That's more or less what I did in the value struct to some extent. Maybe. It's possible. I just think that would probably be the cleanest available. Where instead of having one big union as the value, we have like 3 different unions, all with different possible values. And then by intermingling all those different ones, we end up with all these different structures. It's not, I don't know if it's simpler, so it's not arguably cleaner, but it is a different way to do it. And at that point, we entered the realm of bike shedding. So value and name should be about it. Insert global assignment. Return global assignment. Yes. Okay, what do we got? What do we got? I've been streaming 2 hours. I'm probably gonna have to stop streaming very soon, if not within like the next 15 minutes. So I'd just like to thank everybody so much for watching. Be sure to check out my YouTube for all the previous broadcasts and this broadcast later today. It'll probably be uploaded. And yeah, thanks for watching. Thanks for enjoying. We're gonna continue on up until the very last minute that I can, though. So let's continue this. I keep getting confused. I'm like, why is this not working? But it's because I didn't add this here. Lol. How about that? What did I call it? New value. Sure. Yep. I'm a smart one. Ah, that's why. It's like, wait, this doesn't make sense. Glocal. We're gonna rename this to global store, not Steor. And store local, we're basically just gonna say instruction local store. And this is gonna have just a pair. Sure. We'll have the left-hand side equal the local that should be overdone, and then the right-hand side have the new value. Is that correct? So it says, but yeah, the 2 options you have are basically one giant union to rule them all, and in darkness bind them. Thread says, God damn it, Twitch. I hate it when I accidentally press enter. No. I do that with texts a lot, and I end up sending like, hello, hi, and that's it. And it's like, oh, I'm a full-on, I'm a full-on idiot. It's like, you know that quote from Tropic Thunder? Well, I went fully there. Oh, God. Handle IR type 14. 14. Global address. Heyo. Alrighty. Sorry, I had to deal with the phone notification there. Where was I at? Why was I up here? I totally forgot everything and anything. Oh yeah, case 14. Case IR global address. And this is basically going to be global address. Global address. How do we feel about that? Sorry, but yeah, the 2 options you have are basically one giant union, TM. Easiest to use, very inefficient in terms of space, yes. 2, making every value a different struct with a type field at the start of the struct, heap allocating everything, and a lot of reinterpret casts. Yeah, you can. There's also a third option where you have just 3 unions and they each have all the same type. And instead of having multiple structs, you just have multiple unions. You never need multiple structs. I'll go back and show. I'll show. So this is probably just going to be name. Before I screw that up. Option 2 is basically inheritance. Yeah. Exactly. So what you could also do instead of having all these values separately, like for example, we need an instruction and a char pointer, and an enum comparison type and a pair, right? So all we could have is a little union, right? Which is like A, union B, and then union C. And this could be like a char pointer name, an IR instruction pointer, left-hand side, an IR instruction pointer, local, an IR instruction pointer, reference, right? You could just have it be anything. And then in here, you could say, okay, and then this is an IR instruction pointer, right-hand side. This is also, let's say, what, we need a block here. So for the true branch, so we could say IR block, true branch, and then IR block, false branch. Oh God. Russia says another option, an entity component system like in game engines. Don't think anyone's tried that for compiler development yet. Yeah, I don't know if we have entities. Suraid says, just make them anonymous and throw them in the struct without naming the variables. Basically what you're doing right now. Yeah. So then you can just access all of them. This is the most space efficient, right? This is how you'll get the best the best space efficiency, because you won't have all these structs, right? And put all of those in a giant union. Oh no. Yes. Yes. No, that wouldn't work, because we need the true branch and the false all at once. This would have to be a struct. But this is what our IR value struct could be, which is a little bit different from this. And then all of these different things, like you could even put enum comparison type in here, right? It'd be rough. It'd be an odd way to develop, but it's definitely doable. Beautiful, beautiful. But yeah, there's definitely multiple ways to do it. I just don't know if any of them are clean. You know what I mean? Handle IR type 13. No. No, I will. Global store. Store what into where? Global assignment. With an ID and a name. A. Sraid says, and finally, put all of the... Oh god. First time chat from a new viewer. Kilbabite says, yo, what's up, Kilbabite? Yo to you. What is going on? Thank you so much for tuning in, Kilbabite. Good to see you. So it says not unions. Basically what I mean is take, for example, IR comparison and make an inline struct in value. Do the same for all other structs and finally put all of them in an anonymous union. Namespace pollution go burr. Oh god. Russia says, this doesn't sound too bad. Struct IR value, int type, union, struct IR comparison, compare, struct IR whatever, foo. That's what we have right now. Rusius. That you are correct. It's not too bad. We have a type, and all these different values which go within this union IR value, and then it's just a type and a value tagged union. It's very messy though, just because all of these have to be defined and they're all very similar, but they're not the same is the issue, right? Sarade says, if you commit what you have right now, I can open a PR for that real quick, just so you can see how truly ridiculous it would be. One struct to rule them all, lol. If you want me to, I can. I'll push what I got. It doesn't work. I'll just say something like, yeah, we'll go for it. Yeah, that's for MSVC compatibility. We generate global variables in the backend instead of in CodeGen now. All right, here we go. We're going to say progress made on the 7th of October, 2022. On stream during the 7th of October, 2022. This is for Sir Aid to bless us with the gloriousness of an abominable, horrid data structure. We chill our bones. I might be hyping it up too much. Unmerged. And merged. Perfect. Straight says, I already know what the PR title is going to be. Oh, you working ahead. Handle IR type 1. Is that immediate or call? It's call. Yeah, we don't handle it. It's fair. Oh, this is going to be messy. So we're going to have to put like what we're calling. Okay, so we're going to have to switch, right? On IR call type. Handle the IR call type. So for direct, we would like to say we're just going to be calling a function name. But then when it comes to, I guess I should get the name first. Like that. Okay. What is your issue? Oh, printf needs file. I was like, what is the problem? Indirect is going to be loaded from another instruction. So we're going to have a callee ID. And then after all this, right, then what we can say is print arguments. So we're going to do, yeah, something like that. And that. And we'll say for IR call argument pointer argument equals instruction value.call.arguments. And we're going to say argument equals argument next. So yeah, then we just have to print the ID of each argument after the first. So here's what we're actually going to do. Is do this here. We'll say if argument and handle the first one in a special way. This is a whole mess, I know. And say argument ID. Again, put in file. And then we can say argument equals argument Next. And then in here, we can just print out a comma first. I just screwed that up. Not bad. You didn't commit intermediate representation H and C. Maybe it's in your git ignore? No, I probably just haven't tracked it yet. They're easy to miss up here. Yeah, look. Hey. The rest of the owl. That should work now. I drew the rest of the owl for you. There you go. You get that reference. Bog. So it's just nice. Yeah. I'm just not the smartest. So yeah, this should work. If argument. So we'll only do anything if argument. First time chat from Red Candy Eater. What's up, Red Candy Eater? He says hi. What's up, Red Candy Eater? Thank you for tuning in. How's it going? What's good? We have some sort of Noldy reference going on. I don't know what it is. We'll figure it out. Probably right here. Ah, we're just missing a break. Right here. Well, that's one thing that went wrong, apparently. There's still more. Red Candy Eater says, I'm well. I've been looking into UEFI bootloader stuff and assembly. Well, you've come to the right place. I've written a UEFI bootloader. Why are you mad now? Value call, value name was null. So callee is null putter? It's just saying it's confused because of the union. Unable to read memory. Interesting. So callee being null is kind of an interesting one. How did that happen? How do we generate a call and not set the callee? You telling me we're passing null to indirect call? Expression children result. We never code gen the child? I think this is where we're at. So we just need to code gen the actual call itself. IR fmet instruction handle IR type 12. I think that was it. Global load. Global load. Red Candy Eater says, I read you can use LLVM and avoid GNU EFI and the tools needed to convert to the PE format. Well, you can use anything. Red Candy Eater says, well, maybe it's Meson and not LLVM. I was the one that actually made the pull requests that allows that to happen in Meson. I was the one that wrote that. So you are correct. You can use Meson to generate executables that work in the UEFI subsystem. Red Candy Eater says, is this a C compiler for your OS? No, this is just a compiler for a language I made up for fun. This is just my hobby. Well, one of my hobbies. I'm also creating a written language, but I'm not doing that on stream. But yeah, all of the code you see here has been written on stream, and it's all on my YouTube and stuff like that. So yeah. But yeah, if you're trying to avoid GNU EFI, you could even just use the raw function pointers themselves of the UEFI hardware implementations. If you want to check out what that's like, you can actually go to my check out my GitHub, and I have the RADI bootloader, RADII, and that one actually is a UEFI bootloader, like written from scratch, which is pretty fun. And you can even write your own kernel on top of it if you'd like. It's completely open source, or it should be. I don't think I have it licensed yet, because I'm still I was working on it like a year ago when I was ignorant. And yeah, the Ratty isn't built well, I'll tell you that. It's not the best one. Red Candidator says, that sounds awesome. That's awesome. I'm glad it sounds awesome. Red Candy Eater says, I'm planning on making an OS in a custom assembler with super optimization. What is that? Super optimization? Is that like optimization, but way better? That's really cool, Red Candy Eater. I would love to follow the development. Is there anywhere we can check you out or keep track of what you're doing? Hey, we did it. We did it. I'm going to do a slight pushy. Because this is all we needed to actually get to it. And I will get to that. It's not important to have it right now. That's really cool, Red Candy Eater. That is very cool to hear. It's impressive that you're trying to make an OS. Most people would never even dare. See, we want this to be the return value. So we have a little bit of some issues happening here with the return value thing. How is that happening? Return value is very much not 4. Return value equals last expression result. Well, then why does all this stuff? It should be the... Why is the function call in the wrong place, is really what I'm asking. This is correct, but the function calls before the arguments, which is a little bit of an issue, right? What is happening even? Ooh, this is very broken, is it not? Let's see. Let's see if we can make any sense of it. We're going to take a look at the examples, greatest common denominator. We'll open up editor, load file. Okay. What do we got going on? So we have Euclid, GCD Euclid, which is a function, returns an integer, takes in 2 integers. So it says, all right, I have opened the PR. Oh. That was fast. That was fast. Red Candy Eater says, it's like what compilers do, but they use brute force and that allows it to find more improvements. It also takes much more time, but it would be great to have background threads doing that while doing other stuff. That would be crazy. You're gonna have to deal with like concurrency then. It's gonna be a whole thing. Look at my works, ye mighty in despair. Also, I forgot to merge the docs. My bad. Disclaimer, this is a joke PR. Do not merge. Click. Inlined everything. Oh no, there's not even a type anymore? No, it's probably just been inlined. Yeah, so you inline the type. Then a union with... Oh no. Oh no. This is horrifying. See, we could even take this further. This is beautiful. This is beautiful, though. Oh, and then it's a struct of... Oh. Oh. An anonymous struct of anonymous structs. Oh no, these aren't anonymous. They got names. First time chat from a viewer, Phasma122. I'd like to make an OS, but I don't know where to start. Go ahead and... If you go to my GitHub, there's an OS. You can look here. That's somewhere to start. And then there's also the... you go to old commits, like very old commits. Here. Look at this little trick I learned after having to jump back hundreds all the time. So if we go back to an old commit and look at the readme... Oh no. I just want to look at the tree. Yeah, there we go. Poncho's GitHub. So if you don't know, Absurd Poncho is Chad. Very awesome. And this person, you can find him on YouTube as well. Just Absurd Poncho on YouTube. You can find him somewhere. But there's an entire series on making an OS. I don't want to click on this because I don't know what it is. Here we go. Poncho. This person on YouTube has a bunch of tutorials on OS dev that helped me get started. I watched this season 1, and it was beautiful. Season 2 helped me with keyboards, but that's about it. But yeah, check out Poncho on YouTube. It's that's how I started. And then I was like, hey, I could do this. And then I did it. So I believe in you. It's definitely a possibility. Red Candy Eater says, what do you think would be the simplest way to compile and link a UEFI bootloader on Debian with the least amount of includes and maybe an assembly? I don't know what you just said. What would be the simplest way to compile and link a bootloader on Debian with the least amount of includes and maybe an assembly? I mean, it's the same way you compile anything. I'm not sure what you're asking. You just need a to generate a PE32 executable, right? Don't they literally have on Debian in the package manager, like you can download MinGW or W64 MinGW, right? I'm pretty sure. I could be wrong. Emacs freaking out. Oh, but if you do... I don't know, I remember a bunch of stuff. But if you did like x86, 64, W64, MinGW, VCC or something, it's something like that, crazy. But it's basically, you can get a Windows compiler, cross-compiler from Linux to Windows for GCC, and then you just use that because when you generate a Windows executable, it's in the PE32 plus format, which is the same that UEFI requires. Then all you have to do is set the subsystem, which you can use dash subsystem equals like 10 or 13. I can't remember what it is for UEFI. You can look it up. The PE subsystem, PE file format subsystem. But you just set it to the right subsystem. This is also the exact change I made possible in the Meson build system. But you just set the correct subsystem after calling your like W64, MinGW, GCC or whatever, right? And it's probably x86 64, something like that. And then you just pass it any files. So that could be assembly or C or even Ada or NAT, using NAT, or you could, you know, there's a lot of options. A lot of options. You could do C++, G++, anything you want. Just make sure you compile it to the proper PE32 plus format with the proper subsystem, and UEFI goes, hey, I know what that is. It's never simple, to answer your question. So we should have GCD Euclid. We have global address .L0. I'm not sure. So we're getting the global address of a label. I'm not sure this is correct, right? I'd be a little suspicious. So functions returns beginning of instructions address. Result is a string though. We'll see. So we load a global address. This seems so wrong. Shouldn't this be GCD Euclid here? Serraid says it's the label at the start of the function, then it's correct. All right, that's confusing. That's cool. It can be the label at the start of the function, I guess, if we use the result as it, but it's not set anywhere else. I guess in CodeGen function it is. This is so messy. It's not GCD Euclid because the way the function name are handled is scuffed. Yeah. Okay, we'll get better at it. So this is correct then. So we load this proper function address. Then we store it in GCD Euclid. Okay, so this is like the lambda. Because right now we're storing the function address in a global variable, if you recall. That is how it works. That's true. Yeah, so we're basically loading this lambda address, lambda 0, into 1. Then we store 1 into GCD Euclid, the global variable. Then we load GCD Euclid. Then we call this address with no arguments. What? What? I don't think that's what happens next. I think this may be the issue. So let's think about this. Where is it? Direct call, indirect call. Okay, so we need the call to be created. Otherwise, we can't add function arguments to a call that doesn't exist. But then we also need it to be inserted after we codegen all of the arguments. So it's like we need like instruction here for IR call, right? And then we would we'd do this little comparison. Yeah, okay. This is a mess. And instead of saying expression result equals blah, we'll say expression result equals call, right? No matter what, it'll equal call. Then we can just say call value call type. Yeah, equals IR call type indirect. Serraid says, I solved this by iterating over the arguments twice. First to omit them and then to add them to the call. That would also work, I noticed. Because if we didn't add them, then they would already be codegenned and everything's fine. But I'm stubborn. Screw it. We're not going to do it. So call type is indirect. Direct. And then we can say call value dot. Oh, I know. This is not the best, but it's okay. What is name? Where did I get this from before? I got rid of things when I should not have. This is the name. Yeet. Okay, so call value dot call dot value dot call eat no dot name. And then this is probably expression children. Hey. Red Candy Eater says, what the hell? I installed Windows and I found out why I can't see my application shortcuts. I don't have permission to read them. I mean, you could do some dangerous stuff with application shortcuts. No, Windows is just trying to keep you safe. Why is this here? This should not be here, I don't feel like. And then we should just say, what? Then we just have to IR insert into the codegen context the call. Pog. That worked. Hey. So we load the lambda, store it in the global, load the global, set up the arguments, call it, but with no arguments. Is this a joke? Okay. IR add function call argument. I see. Yep. Exited with code 5, that's how we like to do it. No, what'd I do wrong? So I set arguments as an iterator, and then I go all the way to the end and set arguments next to the new argument. Seems fine there. So if not arguments, it equals this new thing. The problem before was we weren't updating it. So now we have a very similar issue. Argument value is null pointer. That's a good point. Can't argue with that. God damn it. Oh, well, we fixed it. Hey, look. It works. It works. I mean, not for the other function, for some reason, but it works. Awesome. So this is the main function of our example. We have GCD Euclid assigned to a new lambda. Then we call this lambda, we load it. We load 88 and 32, and then we call this lambda 3 with 88 and 32. Look at that. And we return. That's Pog. 6 is our return value. I like it. I think this is okay. What if our return value should just be a copy of something rather than just a pointer? I don't know. That may make it easier to generate. Red Candy Eater says, when I install Linux, I use Debian with the live environment LXQT. I have not learned how to install it from memory. Lamau. I'm still running Windows, sadly. I'd love not to one day. Love not to. So why aren't we generating IR for any other functions? So function equals new function. Function next equals context function. Context function equals function. What is block? Block is the new block, okay? So context function and context block. See, this should add to the linked list of functions. Everything should be fine here so far. Everything is making sense, but we still only get one. See, we should get 2 functions. Because this is a function here. And then this whole thing, the main function, is one thing as well. I wonder where am I going wrong, right? for node type function, we do cogen function, which does call IR function. So let's just printf here and see what goes on. Also, I really gotta go. I'm so late. So we do get here once, which means that we should have a function that we're generating. See here with .l0. But this is main, this is not .l0. So where's .l0? Where's this function? How does it disappear? Maybe we're not properly, I don't know, doing it in the emission? So we say function equals function next. So we're definitely going through all the functions, right? Or is it just nothing's happening? Nope, only one function. So, somehow this isn't working. I get it now. I get it now. So what if we just did function? I think it would work. It didn't. Okay, good thing I'm wrong. Good thing I'm wrong. Damn. Okay, so when we do IR function, here's the thing. We say if not all functions equals function. But we build it backwards. So really, all we're saying is context all functions equals function. So we can just create a singly linked list with function itself. And we don't need all functions. Because the function itself that we added to most recently already effectively, right? It already has issues. So I'm just curious with IR function what's happening. So we create, for example, the main function. That's not good. Ew, move this. Where are we at? So this function f seems like it should be in the context, but it's only in our current cogen context. So do we have to go... Red Candy Eater asks, what is making you stay on Windows? Data, NTFS file systems. That's about it. I just don't have a big enough computer or enough money right now to be able to transfer all my data to a new file system and back it all up. And then once I have the backups, then I have to back up those because now they're on a new file system and I want to get rid of this old one. So I still want to have 2 copies, which means I then have to copy those, which means I then have to... Basically, it's a lot of just hassle. That's what's keeping me on Windows. Hassle. But one day I'm sure I'll just switch and I'll just go, screw it. So my theory is that we're passing in a cogen context that's then being eaten. So what we need to do is reorder these. Expected char pointer. What's the issue? Cannot insert into a closed IR block. Content block was null putter. The classic, right? Context block being a null putter. How did that happen? Just by me moving that. How did that happen? It doesn't make sense to me. Let's check out the call stack. In IR load local, we're trying to insert and we can't because our context is null. Because we're in cogen expression. How's our context? I'm just so confused. How are these all null? How's there no function? This makes no sense. The fuck? Ah! Okay, so let's think about this. Do I then have to do like cogen context function equals f? Cogen context block equals f first? And then it says cannot insert into a closed IR block. God damn it. Why is it closed? It's my question. So what am I screwing up royally here? LanderXT says, I'm finally back. Hey. I'm screwing something up real bad. So we're gonna get the global context. Okay, so now we have the global context. I want to say the global function is updated along with our current function. Right? It seems like these should just be copied down. Oh, maybe that's what's happening. Okay, maybe that's what's happening. We're going to try something else first. Oh boy. Okay. Right? Yeah. Yeah. So why? Thank you. So default will have like to do, and this will like handle blah cogen format, cogen output format, right? And then we'll pass in parent format. And then in here, we're going to switch on call convention and say default, which is to do, handle %g cogen call convention, and call convention. Red Candy Eater asks, how much data are you carrying? I just have 100 gigabytes for gaming and 800 for movies. A little bit more. Like 8 terabytes. LanderXT says, I am finally back here. I think I read that. Red Candy Eater says, what Linux distro do you like? Great question, Red Candy Eater. Thank you for the for being interested. I would say Linux Mint, just because it's I don't know, it's just supported by a lot of things. It has a lot of drivers. Seems like it would be one that just works every day, and you don't have to like worry about it. Yeah. See, I feel like we should do something like this. Right? We should have like new context. And then we're just basically going to say create, no, we'll just say it. There's no way it can get through here without being set. Red Candy Eater says, Debian has good support also, and I read it has very good stability, and that sold it for me. Nice. LanderXT says, coming from Windows, everything would be more stable for you, Lenzer. It's true. you'd get a lot less crashes. No, Windows has been okay. It's a fine OS. It's just a little monopolistic and not open source. Red Candy Eater says, my wireless card acts weird when I use Linux. It's kind of frustrating. It might be fine when I get more experience. Yeah, it's always drivers. Drivers are always an issue. LanderXT says, Windows needs to update 10 hours later. I actually did a whole bunch of stuff, and now I don't ever deal with Windows updates. How about that? How about that? On my laptop, it's horrible. It's constant Windows updates. It's every time I want to use it. It sucks. But on my desktop, I did a whole bunch of black magic a few years ago, and now I just never get updates. LanderXT says github.com Windows/Windows. Lamau. Yeah, you know, just go find Windows on GitHub, and there you go. So just bothering me. Okay. And we would like to set new context. Parse context equal to the parent parse context. We would like to set the new context all functions to all functions. We'd like to set the new context function to function. Context block to block. New context call convention equals call convention. New context. What is call convention? Yeah, this is, we want to just pass it all through, baby. Dialect equals parent dialect. Code equals code. Format equals format. Bullet. Register pool, locals offset, locals, function. This is probably both going to change. Function dialect block, arch data, all functions, parse context, format. I think that's it. LanderXT says, wait a minute, React OS, Windows on GitHub? Lamau. Imagine, in 2022. We're gonna do align. Beautiful stuff. Thank you, Emacs. And now, what happens? Handle 0 cogen call convention. Ah. All right. Still doesn't work, but hey, we're closer. Damn it. Okay. So, and at least that's handled better. So we are going to have to get the global. I think there's no other option, really. I don't know how I got around this, or could get around this. Seems like it's not necessary, but it apparently is. Cannot insert into a closed IR block. Well, why are you trying? So at this point, we're saying once we get out of the function, we're trying to go back to this function, but now it has the incorrect block and stuff set. So if we never set it, everything should be fine. But then it's just not added to the proper linked list, right? So what we should truthfully do is say global all functions equals function. Right? That should probably be what it is, but we have to figure this out. ThunderXT says, I can't believe React OS actually stores code on GitHub. Like, that'll get shut down, surely. Fun fact, I made a super cool OS. I promise it's not stolen. GitHub.com/Torvald/Linux. Lamau. Lander, yeah, wow. That's really impressive. You got like 1 million commits on that. You've been doing work. Lamau. Red Candy Eater says, do you have a long-term programming project plan thing? I have no plans of any sort. No, is the answer. If, I mean, I have plans of like work on the compiler, work on the OS, work on the text editor, stuff like that. Not really anything specific. So we want to basically just add to the global linked list of functions, but we also want to say our function equals thing. So we could say function next equals context function. Let's try that. Still says cannot insert into a closed IR block. So we're setting our block. So the issue is we are doing this function, everything's fine, until we get to the end of it and we try and start doing stuff here again. And it's like, hey, you already closed this block and nothing's happening. So it's almost like cogen function should set us up with another function, right? It just shouldn't change in the global, though, is what should happen. That's why I'm so confused. Okay. I didn't do any of that, right? The issue is we're missing a function. And that's because when we create it, we didn't add it to any list or anything that will get, that has anything keeping track of it, right? So we need to say context function next equals function. That would add to the end. That wouldn't work though. You see what I mean? Like we have to somehow alter the underlying function to have a new one. So let's just get the last function. Which equals context function. And then we'll say so get it to the very last function, and then say last function next equals function. Does that make any sense? And then say context function. See, then it's a circular linked list. Why can't this work? Why can't we just not do this? So I have a question. What if we just did not do this? And I know that'd be ideal. So what if we didn't create a new cogen context and free a cogen context? Do we need to, right? Cannot insert into a closed IR block. Still the same issue. So this closes it, but then when we return OK. So in the new context, it seems like Red Candy Eater says, I have so many plans. It's hard stuff, but I get excited about it when I am not doom scrolling on Reddit or gaming. Avoiding arousing stimuli is good for productivity, and uninstalling games, putting distance between you and them. Yeah, I don't have problems with productivity. I have the opposite problem where I overwork myself. So I have to actively put video games and food in front of my face and go, you do this, idiot. Don't just work constantly. Because by default, I just work for 20 hours a day and then sleep for 12 and repeat. And it's like, ooh, that's not healthy. But everyone is different. That's what's so interesting. I have problems staying calm and relaxing. A lot of people have problems not being calm and getting active. It's like, Lander XT says, I see you online but not playing on Steam so often. Do you know how many times I literally open my Steam and go, I'll start coding. I click around my games and then I go, yeah, I'd rather just code. And then I code, or I start researching like random topics. Like recently I just got into language development, like not programming languages, actual languages. So I developed an entire language which has its whole own grammar and everything. And it's already pretty mature. I could translate quite a few sentences. But yeah, I just do random shit. And it's hard for me to not. So we create a new context, and then we want to create a function. We want to create a function and then create the context. But it still says cannot insert into a closed block. So what we're going to have to do, I think, is just say block is closed, open a new block. Right? I don't think that's too insane. Well, that does seem insane. Why would that happen? Because we're trying to create a function. Here's the thing. We want to create the function and then create the context. But we want to have the... Okay. I'm getting the issue now. We want to like restore the function that we were in. This is so complicated. So we want to both have this function referenced. Sorry, it says, I come back and you're talking about conlanging, Lamau. I think my insert function is like 20 lines of code. I recall there being a lot of edge cases. Well, yeah, but I just don't want to handle that edge case in that code. There's no reason to. It does fix it, but it's not the proper problem being fixed. It's just a band-aid, right? The problem is that we're creating a function and altering the context, but then we're getting rid of it, but we also want to keep it. Right? It's like, oh, we want to get rid of this context, that way we can go back to whatever function we were within, whatever block we were inserting in. But then we have to also have this function added to that linked list, right? So before we free the context, we should go like, okay, here's what we can do. We can get the so we need like function, right? We need the parent function. And we need to add to this linked list. This is a linked list of functions. We need to add to it. Also, that's weird. We need to add to it the function f. That is now complete. A. Sraid says, also, you're only ever codegenning one function at a time. There aren't really any nested functions anymore. That's not true. When you're our actual IR, that's correct. If we're codegenning from our IR, but codegenning into our IR, there absolutely is nested functions. How would you not handle that? Right? Kind of confusing. Sorry, I may be wrong. Red Candy Eater says, I read about bootloader stuff for weeks and found out later that I should use UEFI for GOP, so I removed the 8-bit stuff I had. In what state does UEFI leave you? I assume in 32-bit. Wrong, in 64-bit, Red Candy Eater. It's amazing. You're just immediately in long mode. You're just in long mode right away, and you can just write 64-bit code. Isn't it beautiful? But yeah, in my pre-kernel, it's written in assembly, and it deals with all the page table bootstrapping. LanderXT says, I deleted the wrong folder and wiped all of my VirtualBox VMs. No, I'm so sorry. I'm so sorry. LanderXT, I hate losing data. I'm sorry you had to go through that. Sir Aid says, at least I don't recall function nesting being a problem when I was working on the front end, but I don't remember what I did there. Alrighty. The problem is we want to create a function and we want that to insert into that, but then we want to move back into the old function and start inserting into that function once we're done in, cogenning this function. Unless you somehow got rid of the recursive nature of cogenning expressions and functions, but I don't think we did. It looked, I'm pretty sure, the same when I was going through. Basically, how does this function get to the parent context, right? That's just what I'm confused about. Did you just get rid of creating and deleting contexts entirely? But then how'd you get that back to your old function? Because it's not like we're within the main function, right? In greatest common denominator, within the main function. And there's definitely a nested function right here. Sraid says, no, I'm still creating contexts. All right, then, yeah, I'm thoroughly confused. thoroughly confused. So if you create a context, did you create the function before or after the context? That's the real question. I know I could answer this question. I probably should just have GitHub open. I don't know. After. Okay. So like we had it. So when you create the function, you set the context, and you say the context block is block and the context function is function. My cogen function create is different though. What's it do? How do you update you create a new function and then update it within the context. But how do you make it so that the global context gets its linked list of functions updated? Not me. It's a little bit of a circular problem. So we say create, but none of this matters, right? Because if all we have to say is like, this context will never actually have anything set already. So it's confusing. We could set like context function next equals function. But then we have to do like inserting at the head. This is so much. I think it just never resets the function and it just works. Yeah, that's not how it works. It definitely has to do something. Red Candy Eater says, have you tried identity mapping the whole memory? Yeah, that is what we do. But to get an identity mapping, guess what? You have to work in an unidentity mapped memory map. Depending on what your bootloader gives you, right? But if the bootloader gives you an identity mapping, then all you have to do is like bip, bip, bop, bop, everything's easy. But it's usually not so easy because you have chunks of memory given to you that are all mapped low. And it's a mess. It's a whole mess. Red Candy Eater says, when and what made you switch to Emacs in your programming journey? Nothing made me, but I saw Soding, honestly, use Emacs, and I was like, that text editor looks pug. It looks like exactly what I want, where I don't have to take my my hands off the keyboard. And I tried Vim, it was just too complicated and too much. But Emacs was not too complicated and not too much. We're gonna steal the Ozymandias branch. So it's a Soding Pog. But yeah, mainly Soding. He showed me that Emacs exists, and then I dove into it. And I wrote entire text files on, okay, this button does this button does this does this, and then I figured out org mode, and then lots of stuff happened. We use a name for some reason. See, this is so confusing. I'm still confused as to how this works. So we create a new function, set a name or whatever. But then we say if context functions, so this adds it to the end of the list. This is what I'm talking about here. But then context function gets set to F. Do you see this? You add it to the end of a linked list, but you also set the current to F. But we're trying to use those two as one and the same things. So the problem is that we have to add to the end of the linked list and then also have the end of the linked list be what we're adding to. Okay, so context function, we're going to assume is the end of a linked list. So we're going to set it next to function. Then we're going to set context function to function, and hopefully everything should be fine. Because this will alter the existing list, but this won't, does this add to the head properly? I don't know. See, but then our function's going to be lost still. We're just going to have a missing head. Yeah. This is going to be a big issue. Red Candy Eater says, have you read manuals about assembly, CPU, or UEFI? I mean, I've read a lot of the Intel manual and the UEFI manual. They're kind of needed if you're going to do OS work. You're looking at them all the time. Context function was null putter. Context function was null putter. This still may be very wrong. We're getting closer. We're getting closer. Hey. Handle IR type 9. Is that subtract? Nope. Local load. Okay. Haven't handled any local anything. That should be fine. Yeah. What are you mad about now? We will see. Value block was OX10. Huh. I have a feeling we're doing something wrong with local load. Huh. I wonder if that's what one of these warnings is about. Yeah, that would be the issue. Red Candy Eater says, do you have a daytime occupation? I do not. At the moment. I mean, unless you want to count this, which I wouldn't. But yeah, no. Luckily, I can get away with it right now. Sraid says, I mean, it's been like, what, 2 weeks since I implemented the IR? I don't remember every last detail about it anymore. Sraid says, ah, yes, casually Malik's the 0 page. Lander Lamau. Lander XT. I don't see it anymore, but I just had a notification on my phone that said, I believe I have upped the fuck, which is hilarious. Oh. So the problem is, yeah, local variable loading is going to be overhauled in a major way. That should be like that. And now we can get another error, I'm sure. Value block was 10. When it says value block, it means value reference. It's just a union, so it doesn't know which name to use. So reference is still 10 somehow. So this is the only load local. So we'll probably have to environment set. See, it should still be being done here. The variable declaration, this should be working. How's it reference 10? God, this is annoying. Ugh. Somehow this is still being set to 10. That's not 10. This is the only place it should be set. So amazing. That or you're accessing the wrong union member. Yeah, that's what it would be like. But we're not. We create a local load here. Right? And say value.reference. That's what we're using here. And then we just get its ID. What's the issue? Right? Oh boy. Why are you so angry at me? Has an ID of 8. Its value is 10. Would you look at that? Yeah, just 10. No reason whatsoever. Okay. How could this happen? This literally doesn't make any sense. So we have a local, which we set as an IR instruction value in local reference, and then we say environment set in locals. Right? And then we say, yep, load a local from this. Printf debugging time. I don't even know what to printf. It's just 10. I already know the values. It's like, oh, it's 10. Cool. I just don't know where it's being set. It doesn't make any sense. It's like we should be loading a global. I mean, having 10 as a symbol isn't going to work either. You know what I mean? So everything's kind of broken. Environment get by symbol. I'm confused. I'm also tired, so that would make sense. Maybe check the warnings? Yeah, we could try. I'm pretty sure there's const fucking errors. A bunch of bullshit with the stupid symbol address. Because this is const for no reason. There we go. No warnings. Damn. Let's think about this. Instruction value block was 10. Why 10? How 10? When 10? Sraid says, okay, ASAN time? Address sanitizer? I mean, there's not much we can do. Again, we just have to figure out when this is being set. But it doesn't make any sense how value.reference is being set to of a local load, right? So value.reference of a local load should be set only down here. What do we got? Local is 10. Yeah, you know, just the IR instruction pointer 10. God, so annoying. I don't know why I'm so angry at this, but I am. Oh yeah, obviously this would be 10. That makes sense. Because it's set here, so why wouldn't this be 10, right? Of course this would be 10. That would make more sense. The real official birdie says, nice Swift. What is it compiling? What? Are you looking at something other than Emacs? Yes. It's 10. Ooh boy. It's 10. So why is it 10? Because IR instruction is 10. Why is that 10? Right? What are we looking for? Which symbol? We're looking for the symbol A? Yeah? That's a little interesting. So we're looking for the symbol A. Yeah, it's a thing. Check wherever you store the alloc, maybe. I mean, we were. Maybe. So we create the alloc here. It's not really crazy. And then we create our reference and say, hey, this is set to that. And we had a breakpoint here, but it never got set somehow. So somehow we're trying to load a local before we've ever... This is so dumb. Before we've ever declared it. This doesn't make any sense, yo. This doesn't make any sense. Maybe it's a function parameter. That's probably what's happening. So why can't we deal with function parameters? What's the problem there? Because they're not declared as variables. So do we have to declare them ourselves in CodeGen function? Like, do we have to go through each parameter? And I'm so confused. Yeah, it's here. Sir Aid, you're a blessing. You're a blessing, Sir Aid. We can now not have to deal with this. We do have to deal with something though, which is a little bit of a problem. Node pointer RAM equals RAM. Thank you so much, Sir Aid. I made paramref its own instruction. We could also just insert stack allocations, but you're probably right that we should have parameter reference be its own thing. How do we deal with that? So we just have to insert a parameter reference at the beginning of every single one of these. So we have to do like instruction param, IR parameter reference. Seraid says stack allocations are too low level of a concept. Not all backends have a stack. I just refer to them by index. Like 0 is the first parameter, 1 is the second, and so on. Well, in that case, we have to change stack allocations. You know? If we're assuming they don't exist in the backend. The backend can then emit the allocates when it emits the functions. But we already have stack allocations in the IR. You're confusing me by saying they're too low level. We already have them. We already use them, right? I could be wrong. Allocate allocates a local variable that doesn't need to be on the stack. That's fair. But wherever you do end up allocating it, you could call that the stack, right? You see where I'm getting to. Why is this mad at me? This was it. This was it. We did solve it. It was parameter, function parameters being sucky. I don't know why I'm using dots, but I think it just looks better in this little syntax we have going here. I just find function parameters easier to deal with when they're a separate instruction. Maybe that's just me being used to LLVM again. It could be. We'll never know. What is 15? Comparison. Oh boy. Okay, so what I'm gonna do is instruction value comparison pair left hand side. Ready? Also that's car. And right hand side. We can switch on the type and print something different based on each one of these. Yeah, sure, why not? Value.comparison.type. Okay. Greater than or equal. Less than or equal. There's probably a better way to do this. I do not care. Less than and greater than. And not equal should be the last one. Hey. Serade says, also consider parameters have to be in specific registers, so the backend needs to know whether something is a parameter or a regular variable. You can allocate a variable for a parameter and copy the parameter into it, but the parameter itself should be different, IMO. That's a fair argument. No, I can't fault you there. You are correct. The parameter itself probably should be different because we need to know like the index of the parameter. Otherwise, we don't know what register it's in and all sorts of things. That's a good idea. You're correct. So it says parameter itself should be different. What was I doing? I was just handling IR comparison and then it said 5. That's what I was doing. Branch conditional. Okay. We'll start with a branch. It's just going to be... Yeah. Branch to le. And then branch conditional. Then we're going to have the condition. And then the blocks. So the condition ID, the true branch ID, and then the false branch ID. Okay, we're getting there. And finally, handle IR type 8. Is that a phi yet? Let's subtract. That's a code 5. That's what I wanted. Why'd we code 5? Did I miss a break down here or something? No? Screwed something up. I don't know what I screwed up, but I screwed something up. Sorry, it says C, LLVM does make sense sometimes. Maybe. Maybe. Return value was null putter. How did that happen? That's a little confusing. So last expression wasn't null, otherwise we would have stopped there. Yeah, I don't even know. It just says function return value was null putter. So maybe it's the main function? See, we say if last expression here, main return value. Just exited with code 5. We did print out here. Just says null putter. I really don't get that. So how would last expression result? There's no way that could be null putter because we cogenned it. I don't know. You probably didn't set a return value for main. I think I did. And it's not main that we're failing at, if you take a look. It's actually, main is fine. It's actually this other function. And I have no clue, because it makes no sense. I just set it, and it's null. How's that one work, right? Just says function return value? No. Function next, also null, which is a confusing one. No, it's because it's at the end of the linked list, but what's the big deal? How did it not get set? Is what I'm confused about. Like, wait, what control flow did we take where that ended up not happening? What are you mad about? Last expression result is null putter? How does that make any sense? What? Okay. So, okay. We codegen this expression. And then after codegenning and there's no error, then we say last expression equals expression. So somehow we have not set last expression result for a function call, I guess. So I guess, I don't even know. We set it to call. Why is it not working? That is the last expression, no? A function call, definitely the last expression. We have a reassignment, a very lengthy one, and then a function call. What? Oh. I'm not exactly certain how this is working then. Or not working. That's a confusing one right there. That's like gigabrain moments. I don't know what's going wrong. So we have a call instruction, and we set the expression result to that. Unless we're returning error and not handling that somewhere, which would be a bigger deal. Bigger deal. Saraid says nasal demons, probably. Yeah, it's actually allergies. That's what's going wrong. I like you, Saraid. Expression result. So just print call. Oh, good. You don't do anything. It's not null. Ah, maybe it's an if. Maybe it's the if. It's not the function call. It's the if at the end. Ah, I get it now. I get it now. Ah. That was rough. It's not the function call at the end of the if. It's the if at the end of the function. Oof. Oh, there it is. There's that big boy. Oh, yeah. There it is, baby. There it is. Oh, yeah. Okay. We're then going to have some amount of if phi argument. So IR phi argument arg equals. I wrote those in the wrong order. I'm real smart today. Okay, so for each one of these args, well, first of all, I'd like to do this. And print to the file. We're just going to steal Sir Aids. Sir Aids. It sounds like I'm saying AIDS. No, Sir Aids' method of printing them out. Okay. Okay, take that same thing, pop it in here. That's a mess. A little better. Oop, break. Not too bad. Sir Hade says, I mean, dereferencing null pointer is technically undefined behavior, but that's not what I was trying to say, lol. By the way, nasal demons is C slang for undefined behavior, in case you didn't know. I didn't know. Lamau. Sir Hade says, told you, if code gen is horrible. Unrelated, this reminds me of how the C++ standard defines the behavior of standard unreachable as invokes undefined behavior. Yay. We did it. We fixed everything. It's happening. And look, this is actually quite complicated and very broken. Why is loads all of 0? That's not good. How could that happen? Ah, that's how that could happen. Wait, how are we not hitting this then? That's confusing. In any case, it's working. So this is the actual parameter reference. Which is interesting. Okay, now I really gotta go. So if it's a parameter, also parameter, lol. Pingbun says got a typo. He said that way long ago. But he was referring to this right here. Thank you, King Buns. So parameter reference is now better. Why isn't this working? It's because when we load a local, we're just saying that's the ID. But the parameter reference, are we not actually inserting those? Did we never do that? Yeah, we probably need to insert those. Is that gonna work now? That's gonna work now. Hey, Pog. Sarade says nasal demons is a reference to the fact that the compiler is allowed to do basically whatever it wants when it encounters undefined behavior, such as set your PC on fire, erase your hard drive, or make demons fly out of your nose. Someone explained it that way once and it stuck. I like it. I like it. So now you can see our main function, F1. And you can see that it has a single basic block, which ends with a return branch. And it basically loads a lambda address, stores it in GCD Euclid, loads GCD Euclid, and then calls that with 88 and 32 as arguments. When we call this, we are calling this function, apparently. We got to have some way to better represent that. But when we call this function, Sir Aid says you can clearly tell the difference in code style. F1 versus underscore underscore function underscore 0. Yes. That's true. It's true. It turns out the underscores aren't needed. No, I'm just joking. I know you know that. So BB2, so this function, which is this function, starts with a basic block right here. So it says parameter reference 1 and 2, which is just the parameters. And then we actually have the beginning. So we need to load A and load B. So we load A and load B, local loads of these. We should also have these be parameter accesses if they're not local variable stuffs. We'll get there, we'll get there. In any case, we can then have 12, which compares 10 and 11, equal 10 and 11. Also, I'd suggest writing compare equals 10 equals 11 instead of just equals. Well, you see, if it was if it was all in parentheses, it wouldn't matter. It'd be clear. No, I'm just messing with you. Yeah, we can do something like that. Compare. How about that? How about that? We could also just do like this. Equal, greater than, equal, less than, greater than, right? I don't think this is an issue either. Yeah, I think that's the way to go. Just use the 2 letters at the end, because that's better reading. So parameter reference 1 and 2, local load 8 and 9, which is A and B. We go back to greatest. Compare if they're equal, and then branch on a conditional 12. So branch on 12 to BB3 here, or to BB4 here. So if we go to BB3, then we have a local load 8 and branch to BB8. So we load A, our first parameter, and then we branch to BB8, in which case we return from this function. Oh, that's beautiful. And as you can see, because BB3 may be the result, then this phi node in BB8, this actual result, this value here, may be 14. It may be A, this local load right here. But there's another control flow, right? We may jump to BB4, in which case we load A and B again. And then we say, is it less than? And if A is less than B, then we jump to BB5, in which case we call, we load GCD Euclid, load A, B, A, subtract B minus A, and then call 21 and 24. There's a better way to do that, but it's fine. Also, I would suggest resetting the instruction numbers at the start of every function. We can. It's just that the idea is that the functions in basic blocks are kind of just organizational. They're not really needed, right? So by having all of them numbered in this way, then you can actually, like, throughout the entire program, the IR, you can keep these same IDs. Unless you have to add more, in which case everything breaks. Sarade says, yeah, but still. Why would it matter what number this is? These aren't for anything. They're just unique IDs. So the fact that they're unique means no 2 instructions should have the same one. The number will grow really large at that rate. That doesn't matter. Right? This is just for debugging. It's not like it's anything specific. It's not like it takes more memory as it grows larger, like in Python. It's the same amount of memory, same everything. which means, okay, so we were at BB4. So we go to BB4, we do the less than and branch on a conditional to BB5 or BB6. In BB5, we do this. BB6, we do this. In either case, after the function call, we then branch to BB7, which is like here, right? At the end of this if. And then at the end of BB7, we say phi on either this value or this value, and that is our value, branch to BB8, and then BB8 says, hey, that may be my value. So this if may return the result of this if, which may return either this or this. And that's what these phi's represent. Are these numbers correct? 32, yep, function call. 25, yep, function call. Also, I think you were talking about parameters and maybe you missed this. Also, in general, you need to allocate a local variable to a parameter because you can assign to it. I mean, you could still use a register and assign to the register. It doesn't need to be a local, right? Pretty sure. Pretty sure it'd be okay. I may be wrong based on caller saved registers, but we'll see. Sraid says, if you look at the code that Clang outputs, for instance, you'll see that the first thing it does is allocate a variable for every parameter and store the parameter into it. There are no registers in the IR, it needs to be a proper variable. I don't know what that has to do with what I just said. There are no registers in the IR. I know that. Doesn't matter. Instead of having local load, you could just have parameter access. And then you could say, oh, just access the parameter in its whatever the register is, right? The parameter access could just say, oh, do nothing. And then in whatever uses the parameter access could just use the register instead. No, that doesn't work. Because what if you store to the parameter before that? What if you store to the parameter before that? So you're saying like, what if we did n equals n minus 1 or something? I agree, for an access, you need a new number. You need a local. But for the actual reference, I don't think you need a local. You can just use the register. You can assign to A in GCD Euclid. Yeah. I still don't see what the issue is. Then the register changes. Like if A is in RCX, right? Say A is in RCX, which it would be on MSWin. Then you could say A is equal to 42. Now RCX equals 42. And then if you use A again, now it's 42. Am I missing something? I could be missing something. I don't know. Prove me wrong. I love being wrong. Means I learn more. But I'm pretty sure you could just have parameter accesses just use, just like basically in the back end result in a no-op. And it's just that the, or you could have parameter access copy to the stack if you need a copy. But why, in what case would you need a copy? I don't know. I don't know. On this level, parameters should be represented as variables. They are. It's A, which is variable. Doesn't mean it needs to be the same thing as a local variable if we said A integer. Unless you want to implement a param store and param load. I mean, why not? We already have locals and globals. Having one more wouldn't really be that different. And it's a specific case. Then how are you going to store to a parameter? Would you just write to it? I'm confused at what you're saying. The IR wouldn't change. It's like you just end up with a store. You'd end up with param store with like %4 into %6. Right? You could even just have an index on the right hand side, just have 0. And then %4 would be whatever immediate, right? Immediate 0, 420. Who cares? How are you supposed to store to a parameter if there is no memory allocated for it? By using the register. You can't just local store to it unless you allocate memory for it. Well, you would just store into the register. That's what I'm saying. There's just new instructions that can be handled differently by the backend. I'm confused why you think anything changes in the IR. You just generate the IR. And we'd say, okay, there's param access instead of having local access. And instead of having local store, you have param store. And then in the backend, you can handle it differently. Bold of you to assume that the parameter is always going to be in that register. Not really. You can't just store into a register. Sir Aid, you're talking circles around me. We're talking about the same thing. You're just disagreeing because you're like, no, the IR doesn't have registers. I know that. I'm talking about the Cogen backend. Being able to optimize out the parameter access, but they'd still be there in the IR instructions. I'm not sure where you're missing me. That's not how IR works. Okay. You can say that. It doesn't help me think differently. That's not how it works. Okay. Cool. It's like we're just saying the same things. There's no registers in the IR. I'm just saying that instead of having a param store, instead of having to have it create an entire local variable, or a param reference, create an entire local variable. Based on how it's used in the function in the backend, you could just say, yeah, we don't actually need to store it on the stack. We can just use the register and pass it through, baby. And then it would be much faster. It is how IR works. You create different IR instructions with different types and values, and then the Cogen backend generates all of them in a different way, right? Just keeping to the semantics of the program. What if the parameter is a 128 byte struct? Well, then it would be passed as a pointer. What are you talking about? What are you talking about? We're gonna have structs eventually, right? See, you're just making stuff up. You're just trying to prove yourself right now. You're like, you know that stuff that isn't in the language and we haven't talked about ever? What about that? We've never talked about structures. Structures aren't, at least, they're not in the plan book. They never were. We're gonna have arrays. We may have like, we may eventually end up with something like structures, but they've never been like, let's do structures. And even if we did, they would be passed as a pointer in a register. So I'm not sure what your point is. And then you would just dereference it when you store to it, which is already what C does. So whatevs. We did it. We can emit code for the greatest common denominator, baby. It's happening. The IR is growing. And it's growing, and it's going well. We can do simple math. Hey, oh, accidentally closed it. Simple math. Oh, yeah. We can do, what else do we got? Should we try like downwards fun arg? I don't think it'll work. It did work. Shouldn't there be 3? I don't know, honestly. Looks like it worked, to be honest. I think that would be downwards fun arc. 69. Ooh. See, there's a missing function here. There should be another function, but it's not here. 69 should be a function, which just loads 69 and returns it. But it ain't. That looks... I mean, the main is looking good, but the actual missing function is not looking so good. This will be the last thing I do. And I gotta get out of here. Do something before my brain explodes. So that has to do with like IR function, sadly. Okay. So it's like I want to... See, that's not... This is incorrect right here. If context function next equals function. See, the only reason this works is because... Yeah. So this will never actually add to it. So here we'd have to add to the end of the linked list of functions. And then we say, yeah, change in our current context, change it. Yeah, we'll do it. We'll do it. So our last function is going to be equal to context function. And for function next, last function equals last function next. Last function, we can then say, yeah, last function next equals function. It means next time around we'll get this function as our last function. All I'm saying is that there are reasons why literally every C compiler does what I just described. Sometimes you might be able to get away with reusing register, but that's an optimization. You can't rely on that in the general case. Yes. That is what we were describing. I was saying in the back end, if we created different instructions for the parameters, then the back end could say, hey, in this case, we can just use the registers, doesn't matter. But you're saying we can't always do that because it won't always work. It still breaks my brain a little bit on like when it wouldn't work. I guess it wouldn't work when we use destructive assembly instructions. That's the only case, right? Because if you did add R10 to RCX, now RCX is fucked, even though it shouldn't be. And that's just for doing like A+1, right? It just means that register allocation becomes kind of complicated then. It wouldn't work when you have more parameters than registers. I mean, it never would. Only the first 4 parameters are in registers in this calling convention anyway, or the first 6 on Linux. Then it's on the stack in reverse order. So we always have more than 6 registers, so I don't think we have to worry about that. You know what I mean? But you're right. For our own, if we didn't care about calling convention, we could say run out of registers for parameters. But I don't think we will in the based on calling convention, which is why you can't assume that the parameters end up in a register. I didn't say we can assume that they can in every case. I just said the backend could use the register for the parameters. I don't get why. Listen, I understand there are reasons for doing it. I just don't think we need to do it. Because you would literally just have a parameter access of 0, and then you could say, is 0 below call conv reg count? Oh, use register. Otherwise, don't. Right? It's not the craziness. You already have the index, so you can tell which register or not that it's within. Red Candy Eater says, writing an OS in assembly while not following a calling convention. Oof. That would be rough. Hey, look, I fixed it while talking with everybody. How about that? That looks right. This returns 69. This returns a function that is called from a parameter. And this, yeah. It's working well. Working well. Like Birkenstocks, baby. In that case, I'm going to push everything and get out of here, because I gotta go, baby. I've been late. It's not that I'm late, I've been late. Hey. First time chat from Altos. As long as you know what your calling convention is and what is the function, every parameter has exactly one place you can find it. Exactly. Altos, I like you. I like you, Altos. No, I'm just messing with Serene. I like all of you. I'm just saying that if you don't allocate variables for parameters, it's bound to break or get in the way sometime down the line. Maybe. What is the function prototype? I meant. Oh yeah, you're right, Altos. You're right. You don't have to know the function definition, just the signature or the prototype. And that's going to be very annoying to debug. I'm curious how it's any different from what we have now. I am. It's just going to be that parameter references don't get treated as local variables, which means that when we load a parameter, we would just generate a parameter load. This would go all the way back to the parser, right? Because in the parser, we say, oh, if it's a local variable, then just make a variable access. Right? Somewhere here. Right here. But we could just say, if it's a parameter, right, don't create a variable access. Create something else entirely. A parameter access. And then we could bubble that up all the way into code gen, in which case we would end up creating parameter access instructions. And then in the back end, you just have to find the place to get the parameter from. But then we'd have to figure out, do we need to copy this or not? And then, but because the calling convention already deals with callee saved and caller saved registers, then the parameter registers are already caller saved. So if you want to use them, you have to save them in the caller. So we can already alter the RCX and not worry about it. I think it's, I don't know. I think it's just a different paradigm, right? Red Candy Eater says, unless you make a program to debug it automatically. Oh. Red Candy Eater says, maybe instead of assembly, I could make a custom language similar to it, but with constraints, and make the OS write itself from them. Yeah, that's over my head. An OS that writes itself? Oh boy. That just sounds cool. An OS that writes itself. This is basically gonna be the rest of what was on stream work and on 7th of October 2022. Hey. We did a bit more IR work. Who could have guessed? Okay. Be sure to check out my YouTube. Down below, it's in the Twitch About section. All of my previous broadcasts are on there, so I would greatly recommend checking that out. Also down there is that donate button. Also down there's that donate button. I'm laughing at Red Candy Eater. It says, constraints. I want to marry Bella Hadid. Computer. Cracks fingers. Get to work, baby. You better do it. That's what you gotta ask GitHub Copilot if you ever get invited. Like, marry me to Bella Hadid. Show me pictures of Alexandria Daddario. This is how to use GitHub Copilot. Lamau. Red Candy Eater, you're so funny. The thing is, what instruction would you use for A is assigned to 42 right now? It would become, right now, in the parser, it would become a variable assignment. Reassignment, because that's how we named it, sadly. Right here. Technically it'd be right here, because it's a reassign and not a declaration. But we'd basically say, oh, this isn't actually a variable, it's a parameter, which would be all of a sudden a different thing. And then we'd say, okay, so a parameter has a parameter assignment. Or we could just do a variable assignment, but it's that'd be messy, right? If we're gonna bubble it up, we gotta bubble it all the way up. Yeah, we just change this section a little bit. So after we expect an equals, right? Well, really, we would just expect a different thing. Or we would have some flag set based on if it's a parameter or not. It's not the cleanest, but it would definitely help us out in the later stages. So Surreyed, I see what you're asking. That would have to change, but we would just change the actual nodes that get generated by the parser. Because it can already tell, is this a parameter, is this not? And it would be a little more work. It would be a little more work. We're going to have to loop over all the parameters of a function every time there's a variable access. But it's not going to be a big deal. I don't think. And if it is a big deal, well, hey, that's my fault. I'll take blame. As long as it's working, baby. This is looking good. Okie doke. But yeah, check out my GitHub, check out my YouTube. It is all there. I recommend it very much so. Check out Surreyed's branch if you're curious in how to do intermediate representation the right way, instead of being an idiot like me and just going, let's get it done. Let's do it on video, right? You can be smarter than me, and Surreyed is. I promise. And so go check out GitHub, go check out Surreyed. All the other contributors are now. He hasn't contributed in a fat minute, but he made a golden contribution right at the beginning, and it's still in there. So Surreyed says, see, the thing is just, to me, everything about this approach just screams the front end is dealing with something that it's not supposed to deal with. But yeah, either way. I mean, you could be right. Again, I'm not an expert. I have no experience. This is my experience. You're seeing it now. So don't get your hopes up. In any case, check out all the links in the About section. There's a donate button. Be sure to hit that if you would. I would greatly appreciate any and all donations. The most recent donation by RPWH, $10, and says, thank you for the stream, mister. No problem, RPWH. Thank you. I'm glad I get to do this for you. And I hope you enjoy. In any case, thank you all so much for watching. This is going to be the end of my stream. Goodbye. I will see you in another time. Be sure to join the Discord where you can get announcements every time I go live. And just have a ton of fun in general. Share anything you want about your code, your projects. And yeah, we love open source stuff, so come and check it out. In any case, that's the end of my stream. I did it. Goodbye, everybody. I love y'all. Love you. Bye-bye. Also, shout out to Ropa McCad. Go check out his Twitch. I promise, it's worth it. At Ropa McCad. Go check out that guy. He raided us today, and I thank him a lot. So go check out him. Thanks for the raid. I will see you next time. Tehepelo, says Red Candy Eater. Bye.